was already working for you. people are the ones who you would want to work with without creating any commotion. Okay, but we are figuring it out. We'll sort it out as soon as possible. So don't worry about it. Secondly, we saw some students playing games and doing other stuff on their phones. You can keep your hands down. Thank you so much. Playing games or doing other stuff on their phones. Please do not do that. Let's not take the internet here. Those who have already for granted, because you're seeing that there are some issues. So we are trying our best to get it for everyone. If you have it, let's make sure that you're serious about it and do not take it for granted and start playing games and stuff like that. You might, get that internet banned for yourself and for other students as well if that happens and we get that complaint. And obviously we'll be reporting it then to your colleges, and that escalation and all that things become too serious then. So let's avoid that for ourselves. And yeah, fine. So we'll begin in a minute. Thank you.
Hello.
switch to that then. Podium. The other cam. No. See, वो जो वहाँ पे बंदा है ना, आजकल भी सोचते हैं, जब वो Guys, how's the Josh? My voice was so low. How's the Josh? I am seeing so many silenced voices. How's the Josh? How's the Josh? Perfect. I mean, that was not perfect, but keeping time in check, I think that was perfect. All right, so I think a lot of us would be in a hangover of what happened yesterday here with, Abhishek sir's session. That was one of the best sessions that I attended. And your participation was, I have never seen any more active participants, students, people, in a conference like this, in an education program like this, or even in an attendance of this bandwidth. So that was quite fantastic. So give a clap for yourselves, please. Guys, it's morning. Come on, behave like it's a morning, not a night. Clap for yourselves. So we have a long day today. We will be learning about building stuff in the Polkadot ecosystem. For that, we obviously have our expert here who gave a small intro about small trailer of what is going to come today. So I have known Selva sir for Mr. C. Selvaraju, your expert here, for quite a few weeks now. And I think you couldn't have a better person to come and introduce you the subject, explain you the depth, and build along with you. A man, I have always felt that you can go reach out to him and ask questions. He will listen to you patiently. He will answer your queries. He will take his time, to make sure that you understand the subject, whatever the doubt that may be and whatever time of the day that would be. Even in the night, I've spent a lot of time with him discussing stuff. And I am actually glad that he's here with us, and you should be as well. From the point that the days that are going to come forward in the next couple, especially from 26th onwards, you will need a person like him to help you and hold your hand while you want to, to help you out with the doubts that you will have, because you will have a lot of doubts. Trust me on that. So Mr. Selva has 30 years of experience in training, development, and consulting. He has worked with most major IT companies. Major clients he has worked with has been Verizon, Infosys, Cisco, Wipro, HP, HCL, and obviously right now it's IBC Media, because that's the brand that's going to take over all of the other brands because of you, dear students. So let's give a warm welcome to Mr. C. Selvaraju, and thank you all. And let's begin.
Good morning, ladies and gentlemen. I guess you did not have sufficient breakfast, I guess. IBC Media only provides lunch, I guess. Right? Anyway, so let me tell you something about myself, and then we will start off. So, how many are from computer science and IT background? Okay. Non-CSIT? Good. Only 1, 2, 3, 4. Which branch? Good. Okay. Now, to tell you the truth, I am not a computer science guy at all. No, I'm not joking. I'm actually a major in physics. Okay? I'm a major in physics. But learned computer science out of interest, and all the credit goes to my professors and teachers who taught me. Because in the university, my professors did not just teach the subject, but they also taught how to learn. You see, there are two different things, right? So I've been using that to learn just about everything I can lay my hands on. Okay? And as on today, so in fact, I started my training consulting career from 1990, July 1990 to be precise. That is, over 32 years now. And, I started writing programs even when I did not know what a computer actually looked like. Okay, so my interest actually started with programming in the school days. I still have that notebook in which I had written programs. So in our school library, there was a book on, BBC Micro home computer. So they used to use BBC Basic. So I started writing programs, but even that book did not have a photograph of what a computer actually looked like, right? It was in the year 1988 that I first saw what a PC looked like. And those of you, how many of you have done any assembly programming? Assembly? EC guys. What about CS people? You don't have assembly programming? You have computer organization, right? Just basics, yeah? Is it easy? Okay, so assembly, okay, so I'll ask you, so which processor did you use? 8086, okay. The next, CPU that came from Intel was 8088. The first PC I worked on had the CPU 8088 running on DOS 3.2. And those days, hard disk was a big luxury. Hard disk used to be a big luxury. If the PC had a hard disk, it used to be called as PCXT, PC with extended storage capability. And so I did work on a PCXT as well. And the hard disk size? Can anyone guess? 5 MB. And the PC RAM was 640 kilobytes. And trust me, even in those days, there were a couple of games that were so fast that, we had to slow down. Right? And I think probably it is my generation of people who have seen the most amount of technological, development, particularly in the field of computer science. So from, Intel 8088, and Intel 8088 had one capability. That is, all these microprocessors, they run, using a clock frequency. So you need a clock chip to generate the clock signals, which actually synchronizes all the operations, right? And that was one of the few microprocessors that could support two different frequencies, 3.5 megahertz. I'm not talking about gigahertz, okay? And 5 megahertz. So the PCs used to have a small green-colored button, okay, on the CPU box, and that used to be called as turbo. So generally, the PC will run at 3.5 megahertz, and if you wanted it to run faster, okay, you just press that button, and even if something is scrolling on the screen, that will start scrolling faster. So those were the days. And today we are talking about, multi-core CPUs and stuff like that, and we have already reached, 4 nanometer scale. Okay, that is the kind of technological development I have seen. So I'm very fortunate that I've witnessed all of these in these past 30 odd years. Anyway, so the gist is, one of the important things that you have to understand is that if you have interest in learning, you can reach the sky. Okay? So I was into education, but I used to do this training and consulting, and ultimately I got bored of the education system, the way things were going on. Okay? That same old rote learning patterns. Okay? The only difference when I was working in the university was, university did not have any criteria for attendance. Okay, so even with zero attendance, you could, come and write the exams and pass, get the degree even. So there was no restriction. So I was working in Mohanlal Sukhadia University in Udaipur. Okay. So in that period, I'm basically physics major, so I was an assistant professor in the physics department. But I was known more for computer science because I was part of the, team which brought in the PGDCA programs and then finally MCA programs. So I was involved with that. However, so when I used to teach physics, in the register there would be, we used to have a cap of 75 students per class. Day one I go, out of 75, 5 people will be there. There's no restriction. You can come, if you wish to, you can just stay home, right? There was no restriction on the attendance. So next day I walk in, another 5 set of students. The ones that came on day 1 were not there. Day 2, another set of 5 students. Day 3, a completely different set of 5 students or 10 students. And by day 4, I would lose a track of what did I teach to which person. Okay? So what I did was, all the free time, okay, I started building upon my skills. And that is what has actually brought me here. We had a lot of free time. Okay? Apart from my doing my research, I had free time, so I used to utilize that to build my skills. So as on today, I work with almost every programming language that is used in the industry, including the grand old Pascal and languages like that, even COBOL. Okay? And you should know that COBOL is still existing, right? And the industry is still using it. And then I went on to C, C++ and stuff like that. And currently I work with almost every front-end framework, Angular, React, Vue.js and stuff like that. I'm into full stack development. I also do development consulting and training for blockchains, artificial intelligence and machine learning, okay, data science and all. All of this simply because I actually utilized my free time. I am not on Facebook. I do not use that. I don't waste my time on social networking. And guess what? So what I do is I actually, it's again, depends upon your passion, right? Whether what is it that you want to do. And I've been passionate about teaching. So that's why even though I had a lot of opportunities to join the IT industry, I never did. But of course, yes, I wanted an experience, so I did work for one service industry, one of the topmost service industries in the country, won't name it. I worked there, and when I joined, day 3 I come home and I tell my wife, this is not my cup of tea. This is not my cup of tea. The way service industry works, I can't do this. And 10 months later, when the project I was involved in finished, and the client was so happy that they wanted to give me another project, I said, Namaskaram andi, నాకు project వద్దు, okay, company ni వద్దు. So non-Teluguites, anybody here? Oh, okay, so basically I'm from Tamil Nadu, but we speak Telugu at home, our community speaks Telugu at home, but I'm a total misfit to be called as a Tamilian itself. That's because my dad, served in Air Force, so I was born in UP, spent my childhood in Punjab, my rest of my education in Rajasthan. So when I speak Tamil, people say, are you from North India? That's how people ask. Okay? Right. So we speak Telugu, but because we are from Tamil Nadu, so there's a lot of Tamil influence there. So milanti chokkan Telugu undadu ne maatladetappudu. Right? So that's the kind of thing. Well, anyway, so here you are, even if you do not know anything about blockchain, 6 months down the line, you could be an expert. But remember, one important thing. See, I've been a self-learner. Whatever technology I learned took me sometimes 6 months, a year. But when you have somebody like us backing you, assisted learning is faster. It's always extremely fast. That's why you have teachers, right? Otherwise, once you are able to read and write, you can basically start learning any subject in the world. Also, remember, YouTube is good, Google is good, Stack Overflow is good, but none of these work until and unless you actually practically do and see. So unless you burn your fingers, you're never going to learn the technology. Right? Believe me, that's how it is. Otherwise, every Tom, Dick and Harry in this world would become a domain expert simply by watching YouTube videos. Am I right? But do you see experts like that? So we are there to make you experts by making you to do stuff. So the past 2-3 days have been only talking. Right now I'm also doing the same thing, right? Okay, so, but from today onwards you will actually start your Polkadot development journey. Okay? Polkadot development journey. Okay. Now, one thing I want to tell you. All of you must have learned C programming in the first semester. Which is the most difficult topic in it? The ubiquitous answer would be pointer. Right? Why? Can anybody tell me that? Can you use the microphone? Yeah.
It's because not all the other concepts, it has a different functionality which stores the address of the other value. So which makes actually a little bit difficult for people to understand what is exactly happening inside the power of the stuff. So maybe that could be the reason why people get most confused, as far as I know.
Okay. Anybody else want to add to it? Anyone else? Guys, interact. Don't make it one-way communication. Okay, agreed. But I will not agree to your answers. You know why? I'll tell you the ground reality here. Because when your teacher came into the class to take the first pointer lesson, the first sentence that would have come out of his or her mouth is, today we are going to learn the most difficult subject topic in C programming, and that is pointers. That's it. They will shut your doors and windows of your brain. That's it. This is the reason. And why is the teacher saying that? Because his or her teacher would have done the same thing. So it has become a legacy of sorts. Okay? Legacy of sorts. Always remember, when you start learning anything new, it would seem difficult. You have to patiently spend time. You have to patiently spend time. And you get better and better and better at it. Okay? All of you ride two-wheelers, right? So nobody, you would have started with bicycle? Okay? Of course, parents today get bicycles with all the stands so that the kid never falls down. Today's kids don't have any scratches on their body. Okay? My knees are full of scratches. Okay? My elbows are full of scratches. The next generation doesn't have a scratch on their body. We overprotect them. Am I right? And believe me, all of you are pampered, right? Very pampered. So you are very lucky. We used to get beaten by danda, my dad's belt. Okay? Right. And that too, I come from a defense family, right? So my dad, man, you make a mistake. I still remember. We were in Chandigarh. My dad was posted in Chandigarh. And once I stole, couple of guavas from the neighbor's, tree. So that uncle saw me. So he caught me by the ear and drags me by holding my ear all the way to my house. He was dad's colleague, and he said, see what your son is doing. At that point in time, my dad was repairing a stool. So he was hammering a nail into that stool's leg. He took that hammer, it has a danda. He did not hit me with the hammer part. Otherwise, I wouldn't be standing here. Okay? With the danda part, he beat me like hell. Right? That was our generation. Well, but today, that is not the case. Anyway, so I'm telling you, if you find that you're not able to do something, or it's actually difficult conceptually or implementation wise, I will be there morning till evening, till the last day, and later also as well. So use the Discord, put up your queries, because sometimes people are hesitant to ask in such a big room, okay, with almost 300 people in here. But remember, you are not here to impress the girl sitting next or the boy sitting next. No, you are here to build your own career, right? Remember that. So, let us start off. So, what I'm going to do is, because some of you joined day 2 or day 3, so we will start with, again, it would be a recap of, so you can connect with me on my Twitter handle @TrainerSilva. Okay, you have any queries, you can put it over there. Okay, so we're going to talk about very basics of blockchain and cryptocurrencies. Okay, please settle down quickly. So before you understand what blockchain is, you need to understand what blockchain is not. Okay? It is not a programming language or cryptocurrency. That is the first thing you need to understand. Because whenever you talk of cryptocurrencies, the first thing that comes to your mind is blockchain. Absolutely right. However, blockchain is not cryptocurrency. Okay? Blockchain is the underlying infrastructure over which cryptocurrencies are built. So cryptocurrency is a kind of an application that's built on top of blockchain. And for cryptocurrencies to work, it requires blockchain as its basic infrastructure. Okay? That's what blockchain is. So whenever you hear the term cryptocurrency, okay, blockchain should come to your mind, but remember, blockchain is just the infrastructure over which it is built. Okay? Right. So, blockchain is not a programming language. It is not a cryptographic codification. It is not AI or machine learning. It is not a Python library or framework. First you need to get your facts right. These 2 slides tell you what it is not. Okay? Now we will talk about what it is, how it is built. What's so great about it? Okay? So, Don and Alex Topscott, they have defined blockchain like this. So it's available on Wikipedia page also. So it's an incorruptible digital ledger. That's what it says, right? So first of all, understand. So we know what digital is. Now we need to know what ledger is. So ledger of economic transactions that can be programmed to record not just financial transactions, but virtually everything that has some value. It can be land record. So land is an asset that has a value, right? Now remember one important thing in this, okay? First, whenever you think of blockchain, think of it as a digital ledger. So exactly what is a ledger? It is just a record book of transactions. What is a transaction? Okay, so for instance, bank maintains a ledger. Every business house maintains a ledger. Okay, that ledger contains, okay, I got this much of amount of money from this customer, or money was transferred from account A to account B, okay, and say the customer A deposited certain amount of money. So all this is recorded. This is what really a ledger is, okay. So blockchain is nothing but this. It's just a record of ledgers. It's a record of transactions in the ledger. Nothing beyond that. But look at the human ingenuity in building this technology. The more important point that you have to see is incorruptible. We say it, whatever data goes in, that's it. It becomes permanent. And from a computer science terminology, we say it as immutable. Mutation means change. So something immutable means it cannot be changed. So you might wonder, how is it that, data on the blockchain cannot be changed? So we'll look into that, okay? So basically, what does every block do? A block records transactions. Now think of blockchain as the ledger. Huge book. Right? It's a huge book. Thousands of pages. Every block in a blockchain is a page in that ledger. Right? Every page is actually numbered. Why is it numbered? And imagine that, we have numbered it sequentially. However, you can imagine, think of it like nobody can erase that number. Okay? Nobody can erase that number. So every block in a blockchain has to have a size, because think of it like a book. A book has pages. Pages has certain fixed amount of text in it. You cannot go beyond that. Otherwise, you'll have to make text so small that it becomes illegible, right? So we cannot simply push the entire book on one single page. Okay? So what we do is we create pages. So every block in a blockchain is equivalent to a page in a blockchain. Okay? And whatever you've written is permanent. Imagine writing it with a permanent ink marker, something like that. Okay? And you cannot erase it. Now, in order to have security in the blockchain so that it becomes immutable, all these blocks are connected together. How? So page 1 refers to page 2, page 2 refers to page 1. All of you have studied data structures. A blockchain is nothing but a linked list, believe me. Don't think anything beyond that. It actually is a linked list. Okay? Normally, in linked list, what we do is, from the head all the way up to the tail, every node is connected by recording the address of the next node. Right? So whenever you create a new node in the linked list, you take its address and put it in the previous node, right? Blockchain is just the reverse of it, because you see, how it records is, it's a reverse linked list, in which, okay, successive blocks point to the predecessor. That's the only difference. So instead of your pointers going from head to tail, imagine tail to head. The pointers are pointing backwards. Okay? Pointers are pointing backwards. So think of it like this. Okay? All of you would have, probably read newspapers. Sometimes the article is not enough. Refer to page 5, right? So this is a linked list. You go to page 5 and then you find that text and then you read it. Here in case of blockchain, what happens? In the ledger, transaction recorded, one page is done. When the second page starts, the second page says, I am a continuation of the previous page. So the pointer is pointing backwards. That's the only difference. So how can you imagine a blockchain? You just imagine a blockchain like this. You all know linked list, okay? You all know linked list. There is head all the way up to the tail. So what we call as head is actually the tail. What we call as tail is actually the head in a blockchain, that's all. So automatically, the pointers will all point backwards. That's all there is to it. It is not rocket science. It is not rocket science. It's just simple, plain old linked list. Okay. How the security is built in, that's what we're going to see now. Okay. So in order to understand how it works, we will see all this. Okay. So basically, you need to understand these 5 concepts. You understand these 5 concepts, you know what a blockchain is. Cryptographic hash. It's nothing but, have you studied cryptography? Please raise your hands. So you know what cryptography is, basics. Don't have to go into the details of it. You take some message, encrypt it, and you get an encrypted message, right? That's what cryptography does primarily. So we use a cryptographic hash. You must have heard about the hash. Hashes are used everywhere. Okay. In data structures also we have hashes. All the databases use hashes. Okay. So what is a hash? A hash is a specialized mathematical function which when applied to certain data produces a certain number. That's it. No rocket science again. And you don't have to understand what that function is, how it is calculated. Don't worry about it. You want to know about it? I'll point you out to the resources. Now, the beauty of hash is that, suppose for instance, there are lots of different types of hashes. RSA hash, and there is SHA hash, SHA-256 you would have heard, or SHA-512, SHA-1024, like that. So if you take SHA-256, it's a very standard algorithm which is used. So no matter how much amount of data you put in, it can be one single character or it can be a million characters. It will only produce 256 bits of output, that's all. So it will do some mathematical calculation and you will get only 256 bits. You make any change in the string, the output is completely different. So much so that you cannot find patterns. Like if I add this character, I get this, but if I remove this character, replace it by another character, I get this. So you cannot find that pattern because it is all modulus mathematics. So if you get into the mathematics of it, you would understand. The beauty of this is that from the hash, you cannot get back your original string at all. It's not possible because, you see, generally what happens? Normally when you think of mathematical functions, don't worry, I know all of you are engineers and scared of maths. Right? The most difficult subjects you pass are probably mathematics papers only. Most of you. I'm not saying all of you. So generally, if you have an x as an input, you apply a function f and you get some value y. F of x equal to y. So this is a regular mathematical function, no matter what that is, okay? For every function, there's an inverse function which can actually take the value of y and get you the x value. Like for instance, you take sine of x, you get some value, you take inverse sine of x, you get back the actual angle, right? So usually in mathematics, these are called as two-way functions. A function which is reversible. So these functions will have their own inverse, so that you get back the original stuff. But hash functions are one-way functions. That means you put some input, apply that function, you get some output. From the output, you cannot get back the input. The function cannot be reversed. It cannot be reversed. So that's how the whole cryptographic world works. So how do you protect your data? So you just encrypt. But if that encryption is actually reversible, somebody can decrypt it, right? Apply the inverse function, you get back. With hashes, you can't do that. That's the beauty of it. Okay, that's what cryptographic hash is. You want to know more about it? Read a very nice description about it is available on Wikipedia. Use Wikipedia. Fantastic descriptions with all sorts of resources and links in over there. Then immutable ledger. Now the thing is, when it comes to this ledger which records the transaction, how can you make it immutable? So if somebody is, so if you look at it, what happens is, you could actually hack into the system and make changes, right? After all, this blockchain data is somewhere in memory or some storage device. Somebody can hack into this system and then they can change the data. Hacking happens all the time, right? So how is it that it is immutable? That we will discuss a little later. Followed by P2P network. Have you heard about this? In what context? Computer networks? So I'll tell you, you would have probably used a P2P network without even realizing that you are doing so. I'll give an example. All of you would have used torrents, right? Downloaded movies and stuff with a BitTorrent client, right? What you're doing is using a P2P network. So if you have used torrents, which definitely you would have, okay? So you would have watched movies before the release, right? So that's a P2P network. So what is the difference? See, generally when we talk of a network, computer network, there is always a server sitting in between, right? Usually. So every communication goes through that server, right? So this is called as a centralized network. This is what a centralized network is, where all the communication will go through the centralized server, to which all the various branches are connected. Okay, but in case of P2P network, you have a mesh architecture where one computer can directly talk to another computer. So basically, when you're using a torrent, your computer is not talking to some server. It is directly talking to somebody's computer which has some part of the file which you're downloading. Right? That's how P2P network works. And a blockchain is built on top of a P2P network. So there is no centralized. So when you have a decentralized blockchain, there is no central authority to control it. So who controls it? The nodes which are participating in the blockchain. Followed by consensus protocol and block validation. That is called as mining. So mining is now very limited now. Ever since Ethereum changed over to Ethereum 2.0, they changed over from proof of work to proof of stake. So we will have a separate discussion on this consensus mechanism, proof of work, proof of stake later on, okay, in the day. Because I don't want to spend my time here on this. So how this ledger becomes immutable? Now, remember one thing. See, imagine all the transaction, money exchanging hands, okay, it's being recorded somewhere. So that's what a ledger is. Person A gave 10 rupees to person B, person C, loaned some amount from person X, and so on and so forth. So there is a ledger in which all these entries are made. Okay? This is what is being maintained in the blockchain. So essentially now what happens is, as far as our, we'll take finance as a typical example, banking as an example, because it's easy to understand. I want to send you 100 rupees using Google Pay, Phone Pay, whatever may be the case. Can I send directly to you? Even if I'm using Google Pay or this thing? No. Because there is a bank sitting in between. Either one bank or two banks. If my account is in one bank and yours is in a different bank. So these are the intermediaries. They would have control. So that is how when you do an NEFT transfer, okay, they charge you some money. You have no control over it. Okay? And things are getting worse. Okay? You deposit cash which you have into your own account, the private banks charge you hell a lot of it. Almost you have to pay around 600 to 700 rupees per lakh. Imagine. So I just happened to deposit 10 lakhs into the bank account, and I was charged around 6,500 rupees. My own money, they are taking from me. So banks are the looters, practically speaking. Banks don't have any money. It's all customers' money that they use. It is your money. That's why when a bank, okay, goes out of business, customers lose money. This happened to me when the Yes Bank scandal happened. I think probably just before COVID time. Okay? The government had to bail out. Anyway, so mostly financial institutions, okay, most financial institutions will charge you for everything that you use them for. But you see, why we need to use banks? Because we want to trust. This is what a trust-based system is. How is the trust created? You have somebody you can trust, somebody trustworthy in between. So the transactions recorded by them. So blockchain is a trustless environment. So it's actually a pretty ingenious way of doing it. So see here. So I have 100 rupees in my wallet, I can directly give it to you. Physical transfer. But if I have to do digitally, then I need some intermediary like a bank or some financial institution in between. Right? Now, the situation is even bad when you go to Forex, foreign exchange. Okay? Foreign exchange. So, my daughter is studying in Belgium. Okay? She is doing her engineering in Belgium. She studied in VIT Vellore, and after second year, she got into international transfer program. Now she is studying in KU Leuven in Belgium. So the rest of 2 years she'll be doing there. Now, every year we have to send almost 20 lakhs for her fees and maintenance and all, which government takes in. So when you go to the, when you see the euro dollar rate, okay, say for instance today's dollar rate is, let's say, 85 rupees, okay, and you want to buy dollars, the bank will charge you 100 rupees. They'll say transaction fees, this fee, that fee and all. A dollar whose rate is 85, you end up paying 15 rupees extra, right? And when I come from the US, I got some dollars and I want to sell it, and I want to take Indian rupees out of it. 85 rupees is the rate, they will give me 75 rupees. No, that happens. So they say transaction, exchange fees. In the name of fees, they loot you like hell. Now, if on the other hand, suppose you have $100, I need $100, you know what is the current rate. I can pay you that much money and I can take it directly. So if there is no foreign exchange or a bank involved, I don't have to pay these fees. So I can actually buy from you at whatever agreed upon rate. In fact, I don't even have to go and see what is today's dollar rate. We can just agree that, okay, this is the rate I'm willing to pay, this is the rate you are willing to sell at, and we can do the transaction. Finished? So what happens is, if this was possible, blockchain allows you to do that. I can transfer crypto from my account to your account, or my wallet to your wallet, and pay very, very little fees. But fees is there. So you might say, why fees is there? Well, somebody is contributing to the network and all those things, right? They should be rewarded. So almost all the public blockchains are voluntary. You can accept. So all you need to do, today you want to join the Bitcoin network, you can do that. You can just download their software, run it, and keep your system online. That's it. You are part of the Bitcoin network. For Ethereum also same thing. You need to download their node software, run it, and keep your system online. And you will be rewarded. Okay. So what happens is, now the problem is like this. So this time what happens is, because there is no central trustworthy entity sitting in between to make the transactions, how to validate them, how to trust them, okay? So this is how blockchain solves this problem. So what blockchain does is like this. I'll select, say, 10 people here, okay? I'll say, okay, all 10 of you, you record all the transactions. So there is no central authority. So whoever wants to volunteer, okay? So I'll take 10 volunteers and you will record the transactions. So whenever a transaction is to be made, like say for instance, I give a person X, say 100 rupees. All the 10 people will record it. And then the transaction has to be validated. So they will all compare. So if everything is okay, then it's okay, fine. Good to go. And it is recorded that I gave you 100 rupees. That's it. But in such a system, suppose if I bribe one of the volunteers and say, hey, you know what, I'll give person X 100 rupees, but in your ledger record it as 1,000 rupees, so that I will make him to return me as 1,000 rupees. Possible? Okay. So, all the recorders, so I have bribed only one person. Now, validation has to be done. Everybody says, okay, what is the amount transferred? The majority says, out of 10, 9 people say 100 rupees, and one person is saying 1,000 rupees. Who will you trust? 9 people. This is what consensus mechanism is. Consensus means, the English meaning simply is agreement. Whether you agree to something or not, consensus means that. Okay? So whether you agree that this transaction happened. And so what happens is, in such a scenario, majority is counted. Now what happens? Our system has become foolproof. Right? No. The majority, I say for instance, if 50% say yes, I'll go with them. Okay? So, what I do is, this time around, I have enough money, I bribe 6 people. Then the network consensus will get broken down. Okay? I have bribed 6 people. So now when I give 100 rupees to person X, 6 people are recording it as 1,000, and 4 people are recording it as 100. So majority says 1,000 rupees. So it is recorded that I gave him 1,000 rupees. This is called as 51% attack. So the blockchains are also vulnerable to attack. That's why we are improvising these consensus mechanisms so that this does not happen. This does not happen. Okay? So what do volunteers get? Right? For volunteering. That's where, so that's the reason why blockchain comes with a native cryptocurrency and they are rewarded using that currency which they can utilize. Right? In a physical system, I would say, okay, you volunteer, so you will get some part of the, we'll give you some part of the amount that's been transacted on. So everybody has to be rewarded. It should be a win-win situation, otherwise nobody will volunteer. Right? This is what consensus mechanism is, and this requires P2P network. I can directly go to one validator and I can say, hey, show me your ledger. You get my point? I don't need any central authority. You go and ask a bank, hey, show me the ledger. Will they do it? They won't. Okay. Or you go and ask them, okay, see, my account has 1 lakh rupees. Okay. What did you do with that money? Will they tell you? Believe me, practical situation. Okay. Let's say a bank has 1,000 accounts. If all the 1,000 people come and they withdraw money, all their money from the accounts, you know the bank will close their doors. They never have that much amount of cash. They never have that much amount of cash. That is the truth. They take money from you, invest in all other things, and then, bank has just this is called a cash reserve, which RBI says at least this much amount of cash you should always have. People will come for money here, it's their own money. Right? At that time you cannot say, मेरे पास तो cash नहीं है भाई. Okay? So you can't do this. Right? So that's why the central bank always says that every bank has to have something called as cash reserve ratio. So if the total amount of money is like say 1 crore, okay, 30% has to be in the cash form so that it can be liquidated by anybody who wants to take money out of their accounts. So this is how the whole financial system works. But then again, so what happens is, so now you understand what consensus is? So blockchains are vulnerable to attacks. I'm not saying. So we are improvising on it. Now 51% attacks don't happen. They don't happen. Okay? It was in the initial days. So obviously when a new technology is developed, you will have teething problems. You can't do anything about that, right? So we encounter bottlenecks, we sort them out, and then make this technology better and better and better and better. That goes on. And that's how technology, evolves over a period of time, right? Okay, so block mining, we'll talk about it a little later, okay? So this is all there is to it. So if you take a snap of this, actually there's nothing original here. I have not drawn this. I just picked it, whatever I found right on the internet, and I put it over there for your utilization, okay? You'll have this PPT in the Discord also, or the Discord channel. You can download it from there as well. Okay? So all you need to do is understand these. How many concepts are there? Hardly any. You understand what a hash function is? Very simple. Consensus, how to come to an agreement. So how to come to an agreement? There are various ways, which is what is called as the consensus protocol. Okay? That's central to working of this blockchain. Now, next comes, what about security? Is it not possible that somebody can hack into a server and change the blockchain data? Right? That's where this hashing mechanism comes into play. And remember one more thing. See, so what happens is, basically, the blocks are connected in such a fashion that if you actually try to modify anything in any of the blocks, any data in any of the blocks, you will have to modify data in all the blocks starting from that node all the way up to the first node. The first node in any blockchain is called as Genesis block. Remember, that's called as Genesis block. So you can think of it like the head node of a linked list. That's all. Okay. That's called as Genesis block. So Genesis block means it does not have a predecessor. There is no block before that. Okay? There's no block before that. So cryptographic hash, we are talking about it. So this is what. So I was talking about SHA-256. So this is actual number. I just took it. There are SHA-256 calculators available. You can just give a string and. But the beauty is, if I change anything, even a little bit, even a bit of that input is changed, the output that you get out of this algorithm is totally different, completely unrelated to what previously it was. So that makes it very difficult to decrypt them. And also, it is fixed. The hash will always be 256 bits, whether the input string is 1 character or million characters. So you just cannot decrypt it back to the original value which you input. It's not possible. The first thing, you don't know how many characters do I need to get out of it. Okay. So is it possible to crack it? Yes. But a typical computer would take thousands of years to crack that. The only way to do it is brute force. Imagine we say that, okay, I'm giving this hash, find out the original string. All you need to do is, you start with all permutation combination of A to Z, capital and small case, and see, and ultimately stop when you get the matching hash. You know how much time it will take? So SHA-512 and SHA-1024, if you go, it will take you a million years. You can crack it, but it will take you a million years. Okay? You won't survive to enjoy the benefits of the cracking. So there's no point. So that is how this works. So the cracking is not at all possible. The only way to do is, okay, I'll put one string in the input, I'll see the output, whether these two match. No, okay, I'll take another string, again calculate that, see if it matches, fine. I've cracked it. But this is called as brute force cracking. And it would take you million years to crack SHA-512 or SHA-1024. Okay? They are such strong hashing algorithms. Okay, so going to cryptographic hash. Okay, now this is how the security of the blockchain data is built in. So what happens is, first block is there, its hash is calculated. Okay, its hash is calculated. That hash is put as one of the data in the next block. So the next block has transactions. So those horizontal lines are transaction data. And at the top is the hash of the previous block. You stored it. Then you calculate the hash of the entire block. But this time when you're calculating the hash, it has got the hash of the previous block as well. Right? You calculate the hash, and now when you put the next block, you put second block's hash. So you see, when I was saying this is a linked list, so these blocks are connected through their hashes. Just like you put address of the next node in the previous node in a linked list, so instead of the address, we put the hash values. Because we don't want address, we want the representation of the data. That's what the blockchain is containing. Hashes come into play. So now, so this is how the entire blockchain is built. So the third block has a hash of the second block. Second block has the hash of the first block. The Genesis block's hash is null. So the way you find out if a block is Genesis block, look at the hash, okay? Look at the hash part of the block. If it is null, it means that's the Genesis block. Now what happens, okay? So suppose I want to change, let's say I make some change, okay, in one of the nodes. Let's say hash 2. Oh, sorry, I mean the third block. If I put that, then you know what will happen? This hash will change. But this hash is recorded in the fourth block. So let's say I make some change in the first block. The hash changes. It is no longer connected with the second block now. right? Because second block already records the previous hash before you made the change. So if I make some change in there, I'll have to take that hash, put it in there, second block. But the moment I make changes into the second block, its hash changes, which is recorded in the third block. So what will happen? You will end up making changes to the entire blockchain starting from that node onwards from where you are making the changes. So if you make changes in the third block, you will have to make changes in the fourth block, then the fifth block, and the sixth block, so that the blockchain is still, the integrity is not broken. But then you hacked into it and then you made a change. So what happens now is that when you make a change, you have to make changes to the entire blockchain starting from that node all the way down to the last node. Now see, this entire blockchain security, how it functions. So one is this. It is literally impossible to do that. You know why? The reason is, first off, let's say, even if we talk about the Bitcoin network, you know the blockchain size? It's almost 14 gigs. 14 gigabytes. So somebody has to make a change. Imagine how much amount of changes they will have to, and how many changes they will have to make. You get my point? So starting from that block. So suppose you make change to the, let's say, 1 millionth block. From there to 50 millionth block, you'll have to make changes. It's almost a humongous task. There is another problem also. While you're changing, transactions are happening. And so what happens basically is like this. So every volunteer has the copy of the ledger. So when you become part of the Bitcoin network or the Ethereum network, what happens is that entire blockchain data is actually downloaded onto your PC or your machine. And that is what is used for comparisons. Okay? In the consensus algorithm, what it does, it takes the new block and how it validates. It does some mathematical stuff and all. And so again, agreement has to be reached upon, whether it is valid, this transaction is valid or not. All of them or majority of them have to agree. Now, what happens if I make change? I'll have to. So in the Bitcoin network, there are thousands and thousands of nodes in it. Ethereum, the same thing. And you don't know which network, which node is where. Now, so what happens if you want to make a change? This is how the immutability is coming up. How is it that you cannot change the data at all? How does it become permanent? Because you put the data and then it is copied across thousands of servers, machines. So if I want to make some change, I'll have to make changes to all these servers. Is it possible? Till today, such a distributed attack has never been performed, has never been carried out. Because you cannot do it. Imagine there's another problem. By the time I've finished making changes, transactions had happened, and couple of 100 nodes, 100 blocks have got added. It makes my life even more difficult. Again, I have to make changes into the new blocks and go all the way up to the other blocks and make changes. This is how the security of the blockchain is. So just see, after all, it's a recording medium which is storing the data. I can make changes. But with blockchain, when you collect them through hashes and make it like this, it becomes permanent. This is how the permanency comes into play. So you cannot make changes to the data once you have stored it in the blockchain. You make changes, you'll have to make changes everywhere. No way. It's literally not at all possible.
Sorry.
Okay, any questions so far? Yeah.
Yeah, so everybody will what the question is and they'll also understand.
So, like just now, you have told that for changing a value in the block, it goes on like for really long time, so we can't do. What if they make a change in the last block? So that might be also a disadvantage, right? What does like the thing in that?
Oh, but then you'll have to make the change. See, whatever change you want to make, you have to make it into the entire P2P network. By the time you finish, new blocks would have got added, and whatever changes you made would have become invalidated. So your changes have to propagate to the entire network, which is literally not at all possible. So if you make changes in one, that node will be thrown out because the consensus mechanism will find out who is the culprit here, and it will no longer be, it will be punished by taking it out of the network. So it will no longer be used by the consensus algorithm. So there's no point anymore once you're identified as the criminal.
So, like, if they make from the middle, it is nearly impossible because it's gonna take a really long time to go until then. Like we'll be able to identify it.
Yeah, true.
But then at the last, it's gonna just remove it back because we already know what is happening. Like it's been detected as not the valid one, such kind of thing.
Sorry, come again. I couldn't get it.
Since in the middle, if we start there is some change in the value of the hash,
yeah,
we have to proceed out until the last, right?
Yes, true.
So in the last, it will be able to, like, in the last node, if we make any change in the hash value, it will be able to detect it directly, and it's going to remove that.
So
right?
what happens is, you cannot do it simultaneously with every node in the network. Okay, you are doing it only at one specific node. See, don't think of this as, don't look at it as a blockchain. You think of it like, I have thousands of copies of it. I have to make this simultaneously in thousands of them. You may be able to do it in 1 or 2 or 3, but rest of it you can't do that. By the time you do that, the algorithm would have found out, because you have to finalize the block to be added into the blockchain. So in the last block, when you add, if you make any changes, the consensus algorithm will find out that these nodes are having invalid data. The moment that happens, because until the block is finalized, okay, the block is still in something called as a mempool. So if you make changes there, so it will be identified immediately by all the remaining nodes. So it is virtually impossible to make that change.
What if in future, let's say, what if in future we got up something like we could actually make changes in the hash really quickly? What do you suggest, then there's going to be this restriction or limitation to the blockchain, right then?
Well, always remember, locks are for gentlemen, right? This we all of us know. But the truth is, by the time somebody comes up with that, the security mechanism of the blockchain would have progressed further. It's not going to remain what it is today, right? So it's always a cat and mouse chase. Security and criminal activity is a cat and mouse chase. So when the technology becomes even better and better at securing your assets, okay, the hackers also become smarter and smarter. So it's always a cat and mouse race. So that will always happen. So that's why technology keeps evolving. It becomes better and better and better and better. But see, what you have to understand is the ingenuity of making something secure like this, isn't that? And it will become even better. So it's not an easy task. It's extremely difficult. So this whole distributed mechanism ensures that, things like this don't happen. But if it's a centralized server, okay, if somebody hacks into a bank's centralized server, they can take down everything. That is how, Facebook accounts are stolen, because they are all using centralized, network. A centralized network has a centralized server or a cluster of servers. You just need to hack into their cluster. That's it, finished. You can do whatever you want. But with distributed, you can't do that. Because you'll have to say first hack one, and then the second one, and the third one, and then the fourth one. Okay. And you don't, the number of the nodes which are in the network is too high to make it practical. So what happens is, this is the reason whoever joins a public network, why is it that they are incentivized? Because the more nodes you have in the network, the more secure it becomes. Because you have more number of copies, permanent copies, right? And that is the reason why the incentive mechanism is built into this. So whoever becomes part of the blockchain network, they are incentivized purely because the more number of nodes you have in your blockchain, the better it is, the more secure it is. Because you'll have more number of copies to validate it against when some changes are to happen. That's the beauty of this whole architecture.
Thank you, sir.
Does it answer your question?
Yes, sir.
Any other question, please? So, can we switch back to the PowerPoint presentation? Yeah. I have already explained this. Okay, peer-to-peer network. Okay, right. That's it, I guess. This is what all blockchain is about. Okay. Huh?
Guys,
So now I can take questions.
yeah.
And after this, the next session of mine would be actual development environment. So you have all of you have got internet connectivity? So we'll sort that out also. And after that, once those of you who have, you can download the VirtualBox, and install it on your system. Okay?
All right, so guys.
So because I'll tell you, to save up on time, I have a virtual machine with all the tools and everything installed. It's a VirtualBox VM. So we'll be passing it on to you. You'll just copy it and take the VM up and running. And how I did that, the entire installation instructions we will go through, okay? And we will be providing you with that document so that you can do it all by yourself. The reason is we don't want to spend time on installation stuff, but instead actually doing stuff, right? So installation document is also available, so we'll be providing you with that as well, so that we don't waste time on installation. So just copy that VM, up and running, you're good to go. Okay.
Okay, so guys, see, I am sure. So how many of you got some clarity after this session? Okay. Keep the hands up. How many of you? Please keep the hands up. Please keep the hands up. Yeah. How many of you have some or the other doubt right now? Some doubt.
Oh, come on.
All right. So if you have a doubt, let's sort it out. I mean, we can ask, no?
Please, feel free.
Would you be fine asking the question? Yeah, perfect. So let's do that. You also have a question. I'll come from there. Anyone else? Yeah, perfect. So let's do it this way. I'll go there, I'll come to you, and then I'll ask them.
Hello. Sir, how can we decrease the 51% hacking, sir?
I could not hear. So can you be louder, please?
How can we decrease the 51% hacking? What are the methods nowadays we are using?
No, we are here to build a blockchain, a secure blockchain, not to hack it.
No, how can we decrease that?
Huh?
How can we decrease that?
How many?
How can we decrease that hacking?
Oh no, because basically the original consensus mechanism for validating the transactions, what they would do is, it was built in as 50%. That if 50% say yes, it is a yes, otherwise it's a no. So if you wanted to basically, fiddle with the consensus mechanism, you would need 51%. You get my point? So if there are 10 people and you say, okay, if 5 people say yes, I will go ahead with this. So you will have to bribe another person, okay, to ensure that, your transaction is recorded in the wrong way. You get the point? So it is my rule. So when I change this rule, so now what they have done is they have brought it up to 90%. But there is a difficulty in it, practical difficulty. The practical difficulty in making consensus to I can increase it to say 90%, which means I will have to bribe almost everybody, right? In order to record my transaction fraudulently, right? So the problem here is that, see what happens is, if you try to do that in a human, hypothetical scenario that I gave you, it's easy to imagine. But now look at it as a blockchain which has got, let's say, 50,000 servers. So 50,000 validators are sitting over there, right? So the problem is, even to come to the consensus, it is going to take time, isn't it? The consensus mechanism will have to get the data of validation from 50,000 servers and say, okay, then it has to calculate whether it has reached 50% or not. This takes time. This is the reason why transactions on the blockchain are slow. You get the whole point? So this is why it is slow. I have to go and physically ask every, node on the system, hey, are you okay? He says, okay. Are you okay? Okay. So once I reach that 90% mark, so 50% mark is easier to reach compared to 90%. So because so that way I can speed up my finality of the block and say, okay, fine, we are good to go. You get the whole point there? So the more number of validators you have, the transaction time will automatically increase. You cannot do anything about that, right?
Sir, firstly, when the miner creates a block, like after mining, that gets updated in his local ledger, right? If he is a node.
Okay, so it's like this. So see basically, you have to understand the process of mining. Okay, creating a block is what? Just allocating memory for new block, just like you do in linked list as well. So in linked list, what do? You just create a new node using the new followed by the node structure and stuff like that. It's as simple as that. Why is it taking so much time? See, what happens is the block has to have a minimum number of transactions to be recorded. Otherwise, it's a wastage of memory. So once you have recorded those, then validation has to happen. Okay. So what happens is, in a proof of work, what happens is you have to solve a complex mathematical problem. Whoever is the winner, he is given the right to add a block. So the transactions are all sitting there in mempool. So they are pulled, put in a block, and put it in the blockchain, and it is finalized. Everybody else copies. And for the miner, for having solved that problem, they are given certain amount of incentive in the form of Bitcoin. If it's a Bitcoin network, it will be a Bitcoin and so on and so forth. Okay. So the process of mining is basically who gets to add a new block. So deciding that is what mining is all about. So this process of mining is there only in proof of work mechanism. Proof of stake, we don't have it. So in proof of work also, what happens is one block is added every 10 minutes in Bitcoin network. Okay? So whereas in proof of stake, that's not the case. So blocks are generated at a very fast pace. Very fast pace.
Not like that, sir. Like, I mean...
Yeah, go.
According to you, you said the miner, if he is able to solve the puzzle, then he will be getting the chance to validate the transactions, right?
Validate and then add it to the blockchain.
Yeah. What if he is falsifying the validation? Like, even though the validation of transaction is false, he's saying that it's a valid transaction. Then how can you detect that thing?
Oh, wait. He gets to add the block, but others have to validate it. So suppose, for instance, we take the human analogy. When I'm giving you 100 rupees, okay, and you become the winner of that puzzle, but what happens is you record it as 1,000. Then what happens is, before the block is, you are given a right to add the block, finalize it into the blockchain, but what will happen now is that others have to validate it. A miner only gets the reward because he is given the responsibility of adding the block, that's all. But the validation has to happen across the entire network through the consensus mechanism. That will fail, right? That will fail.
What if the group of validators are major than the true?
That's what 51% attack is all about.
Yeah. What if that situation comes? Like,
in that situation, fraudulent activity will be recorded.
How can it be called a fraudulent one? Because 51% will be accepting that, no, sir?
No, the fraudulent one is because the transaction that I have recorded is not reflecting the actual transaction that happened. Like, for instance, as I told you, right, I give you 100 rupees, but in the ledger, it says I have given you 1,000 rupees. Right?
Yeah.
So majority says 1,000 rupees, it will be recorded. Okay, this is the fact. So majority, so it's like, majority of the people saying a lie and then it is treated as the truth. You get my point? So this 50% can be increased to 75 and 80 and you can ensure that, it is more secure.
And one more thing is,
Yeah.
if the miner is able, if he is able to solve the puzzle, he'll be getting a reward, incentive, right? So who will be giving that incentive to him?
See, okay, so let's look at it. When you say a miner, it's not a person. It's a computer.
Player. Yeah, a normal.
Right? Once the block is added, then the software automatically mints a coin, and then that coin is transferred to that user's account, whose system it is using. That's how it works. It's all automated.
And how the ledgers, like local ledgers, get updated, sir? Like if you have, is it a broadcast thing or it's a ad hoc network?
No, it is a broadcast.
So if there are some 100,000 nodes in a blockchain network, if the miner broadcasts to all the 100,000 members, is it like that, or he'll be broadcasting it to the vicinity members?
No. See, the thing is, it's like this. So basically, how this happens is, because it's a peer-to-peer network, what happens is that the software takes responsibility of passing this new transactions to be added across the entire network. Okay, and it uses various algorithms to make it better and better. So it could be vicinity, it could be direct contact, anything of that sort. It will use a mix and match or hybrid solution so that the data is transmitted across all the nodes in least amount of time. So there are some built-in algorithms which are implemented in order to carry out that. Good question.
And what will be the scenario where multiple miners crack the nonce at a time? Like if they solve the puzzle at a time.
Okay, so what I would request you to do is that you go and read about proof of work where it will be known, because it's possible that 2 or more miners are able to solve the puzzle. So in that case, there is a polling mechanism which actually selects. And this is again an algorithm which will select who is the winner, final winner. So, these are all, are open problems, which is what in future you as, computer scientists will solve. So as of now, there is some, and this is generally not made public, except for this, open blockchains. It's not made public. So you can get information on that, how the Bitcoin, because as far as Bitcoin network is concerned, it's all public. So you can know that if in case more than one miner has actually succeeded in solving the problem, who gets to add the block and get the incentive. Any other question, please?
Yeah, sir, I guess there are some.
Yeah.
Thank you for the clarity.
Good morning, sir.
Good morning.
Sir, the blocks in the blockchain are connected through hashes, right?
Yes.
Let's say the latest transaction has happened and it stores the hash of the previous block.
Yeah. Transaction does not store.
Yeah, the
Transaction
block.
is just a
So the block containing latest transactions store the hash of the
previous block,
right?
yes.
But the hash range is limited, right? It is
Yeah,
only
the
256 bits.
okay, so this is called as, okay, now you're
how
talking
it
like a
gets
computer
to-
scientist. Okay, I'll tell you. So this is called as a hash clash.
Okay.
So there are built-in mechanisms to take care of that. See, I'll tell you something. The same hashing mechanism that I showed you is used by databases also. Why do you need to have a primary key? When you put a primary key in a database, what happens? Your searches become extremely fast. How is this possible? You know what happens? Basically for this, an index is created. An index is nothing but the hash of the primary key, whichever column you selected. So when you do a hash, what happens is, sometimes there are 2 different inputs can give you the same hash value. That's called as a hash clash.
Yes, sir.
That's called as a hash clash. So there are internal mechanisms built in to handle that situation.
Okay, sir.
So databases, what they do, it's like all the hashes are there. When the hash clash happens, so what it does, for that particular, let's say 1 billion records are there, and out of that, 3 records have the same hash, okay? Which is practically that happens. So how the hashes are maintained? So in case of those, what will happen is, there is a separate table generated. In that table, all the 3 records positions are recorded. So if you are searching for something, like say for instance, you are searching by say a roll number, and there are 3 roll numbers that actually match. Then what happens is, you have given in your query that find me a record, select star from this where the roll number is this. Okay, so there will be a hash clash. So there will be 3 matches. Then out of that, which roll number you asked for, it will select that and go to that record. So that is how hash clashes will happen. So you use a second level of solution to handle that. So sometimes you use double hashing also. Okay, double hashing, or there are a lot of techniques to handle hash clashes. If you want to know more about it, you can read about hash clashes. Yeah. Any other question, please? Yes.
Hello, sir.
Yeah. Hi.
Sir, so as you said, miners will be there, that they'll be maintaining the Bitcoin ledgers and all everything.
Yes.
So actually, how many miners will be there, sir, for particular transaction or something like that? Are we having a particular number?
See, no. Anybody can become a miner.
So as you said, 51% attack. So we are having lots of transactions and all. So like, who are these miners actually? Like for a particular transaction, is there a particular number?
Okay. So there is no restriction on the number of miners. Anybody can join the network and become a miner. But the algorithm will only select one who wins the race of solving that mathematical problem in a Bitcoin network, proof of work. You have to perform certain work. For performing that work or for solving that problem, you have used your CPU, you have used electricity, so you will be incentivized. That's how this thing works. Okay, so basically you have to understand that every node on the network is also doing mining.
Okay.
But only one gets selected.
Okay, so out of all those miners, one will be selected and it will go forward.
Yeah.
So on what basis they are selecting that miner, sir?
There are internal algorithms to decide. See, whoever says, I solved this problem. Okay, I'll tell you something. All of you would have probably played, what is that? इंडिया में क्या बोलते हैं इसको दीपक जो बिंगो को?
Bingo ही बोलते हैं sir.
Bingo बोलते हैं. Okay. So when somebody says, okay, he says the number and you mark it, and then finally, so whoever raises the hand first, he becomes a winner. Right? Mining is the same kind of process here. That there is no rocket science behind it. Whoever says, hey, I solved it, validators will say, okay, whether he solved it or not. Okay. And then they'll say, okay, they will agree that, okay, this guy has actually won. So the internal algorithms will actually do all of that work for you.
Okay.
You get the point?
Yeah.
So when you say a miner, don't think of it as a person. It's a computer. It's a computer. So one of the computer will broadcast saying that, okay, this was the problem, I solved it. This is the mathematical problem I had to solve, so I have solved it.
So there is no point of having 51% attacks, right, sir? If one miner is solving that, then
that is a different issue altogether. That is the process of validation, that transaction is okay or not. So it has nothing to do with mining. Mining is everything. That 51% attack means when the validation happens, I have bribed 51% of the systems to report fraudulent transactions.
Okay.
You get the point? So don't confuse between these two.
Okay, sir. Thank you, sir.
So a miner solves a problem. Now he is given the responsibility of adding the block to the blockchain. But before that happens, validation has to happen, consensus. So the consensus is where this 51% attack happens, not during the mining process. Okay?
Good morning, sir. I
Morning.
just picturized the whole topic that I understood in a drawing. So I made
Okay.
a drawing. I just want to show it to you. So is this how it is?
Yeah.
So if transaction happens in this block, so will the hash value of this block also change?
No.
No, it's not like that.
It's not like that. See, the hash is calculated for this block only.
Okay. So if,
That hash will be recorded in the next block.
okay. So if
So this block remains, as is. It will not get affected. It will remain unaffected.
yes. Thank you, sir.
Okay. So when you make changes to a block in a blockchain, you'll have to make the changes from that block all the way to the last block. So again, don't confuse consensus with mining. After mining, who wins? That requires consensus. After that, once a block has to be added, the block is transmitted. Again, people have to validate it. Okay, whether these are valid transactions. Then again, consensus is required. So all these have to happen. So 15% attack is when the validation is happening.
Bingo. So, yeah, any more questions? Okay.
Okay, guys,
So
I think we'll do one thing. I am available here in another next 8 minutes. 8 minutes, right? We have 8 minutes?
Yeah.
Around 8 minutes are there. So within that, we need to close it. I am available here. And in addition, beyond 5 p.m. also, those of you who can stay and you have anything to ask or discuss, whatever you want to do, I'll be here only till the last person goes out. Okay? Even if it is 8 p.m. or 9 p.m. or 10 p.m. I'll be staying there to address your queries. Okay? So I'm available throughout the day.
Perfect. So we have an important
Yeah,
announcement.
one more question I can take, I think. Yeah?
Okay. So
Yeah.
actually, guys, sir,
Yeah.
one thing that was actually quite important is that before we go on to the break, the thing is that the internet issue, all of us, whoever has internet issue, what you can do is basically go on the last, but listen to me before you start moving right away. Go on the last row. We have our team sitting over there, all right? And how we will start is basically we'll take the first one, let's say. Yeah, in the last, please raise your hand. Rajesh? Yeah, please. Yeah, so that's Rajesh. You can go to him. We have TechM person over there. So what we'll do is this row, this row, that sounds like ISRO. This row, and yeah. So what we'll do is, as we move on, so Selva sir, what I would suggest is we take the questions over there only, keeping time in mind,
take that.
so they can sort out the internet by then.
Sure.
Okay,
No issue.
guys, please give a huge round of applause to Selva sir. As he said, he is available here throughout the day, throughout the days, and you can reach out to him, ask him questions, and I am sure we are at a better understanding level right now since we started the day, right? Yeah, perfect.
So conceptually, blockchain is clear now? Is it rocket science? It's very simple. It's just linkless. So anyway, so I hand over the dice to Deepak now.
Yeah, sure. Thank
Okay.
you.
So guys, I'm available, so you can come and discuss with me. I'm right over here.
Right, thank you, sir. So,
Thank you, guys.
Thank you, sir. Sir, do you want me to? Yeah, we can keep the mic there only, sir. Yeah, thank you. So, 1, 2, 3, 4, and 5. So these 5 rows will go one by one, okay? If whoever has the internet authentication issue, all right? Authentication issue with respect to joining the, logging into the internet, all right? Who has over here? And by the way, the break begins now. And what we are basically doing is, when the next session starts, and during the break as well, we are trying to cover these rows so that in the next 15-20 minutes, what we'll do is, we'll cover the last row where we'll ask individually each person to go and sort their internet. So let's begin with the first 5 rows. Over here, internet issue hai? He has, yeah. Please go and join him. Over here, please go along with him. Guys, apart from the first 5 benches, first 5 rows, if you want to go for the break, you can go for the break. And I mean, in the first 5 rows as well, if there's an internet issue, then stay. Otherwise, you can go for the break. Okay, who has an internet issue over here? Yeah, please go over there. Over here. Okay, please go over there to Rajesh. Over here. Yeah, it's okay. You can go over there and check it out. You were there yesterday? Guys, we'll reconvene in 10 minutes. Strictly 10 minutes. This is row 1, 2, 3, 4, 5. Yeah, you can go and check it.
Website isn't responding.
Just that website, yes. And everything else is working, just the IBC website is not working. There could be some issue at the back end of IBC maybe, not from here, so wait for another half an hour. You can tell me or tell somebody from IBC.
Sir, I have told morning.
Which is since morning. last long in this entire process, you know. Yeah, the technology is changing so fast. I'll get to the same point again, that creative thinking is what will thrive. Otherwise, the knowledge that you learn here obviously will be obsolete in next couple of years. What will keep you going will be your creative thinking. And to elaborate more on that, we have two speakers from a company that is thriving because of their creative acumen. So let's welcome with us Mr. Lokesh Indiran and Mr. Rajat Petwal from Wow Labs. Guys, give them a round of applause. Huge round of applause, actually.
Yeah. We have elected to put our trust and money into a mathematical framework that is actually free from human like politics and human error. Hello everybody, welcome to this session. I'm Rajat and I'm here with my colleague Lokesh, and we are going to talk about polka and substrate palettes. So yeah, the multi-chain vision for factory, it all starts here. Yes. So this is our agenda for today, where we will extensively talk about polka and substrate. Yeah, the thing that I just said, it was not actually me who said it. These are the words from this fellow, Mr. Tyler. I think some of you who might have watched the movie The Social Network might have heard about this man. So he was actually a Harvard graduate, and he created Connect League while he was in college, and which inspired Mark Zuckerberg to later create Facebook. And currently he is the founder and CEO of Gemini Reflection. You can say he's a pretty big deal. And this is what we have to say about Polkadot and Substrate. And we shall see why. Blockchain, decentralized process economy. Yes, so blockchain is a distributed ledger which consists a chain of blocks. So chain of blocks, blockchain, it's all that, so simple. And each block in a blockchain contains like majorly three main details of data. First one is hash of the previous block. Then second one is a list of or a set of transactions. And third one is like a hash of the current block. And all of the blocks in a blockchain are linked together or they are chained together using cryptographic hashes. This is how they are. We have this, suppose this is the third block. Third block will contain a hash of the second block. Second block will contain a hash of the first block. And the first block in actually blockchain is called a genesis block. So you might ask what will the first block contain in a previous hash, right? So there is no previous block for the second genesis block. So the int is like it contains zeros. So if you see hash is just it's a decimal number. So it will all the fields will be like all the bits for that will be zero. Yeah. So Polkadot. Polkadot is another blockchain. It's there is a protocol and containing the relay chain at the heart of it. So before talking more about Polkadot, I'll tell you how did we get here. So it all began with Bitcoin. Right? The Bitcoin revolution, the blockchain revolution began with Bitcoin. Where Satoshi Nakamoto he didn't do anything new actually. So he just took some existing technology and he put them together and created a whole new technology called blockchain. Then that technology we saw there was there was one problem with it. The application that was built in one blockchain, and so they cannot talk to the application that are built in another blockchain since the protocols are different, right? So he left Ethereum and he started Polkadot. Where he envisioned like interoperable blockchain. So Polkadot is nothing but a layer 0 protocol with relay chain at its heart, and for the other blockchains connect and communicate with each other. So Polkadot unites and tries to create a whole ecosystem of specialized blockchains, and these blockchains are called chains. So the applications and services that we build on Polkadot in a parachain, they can securely communicate across different parachains. Thus, it forms the basis of like a truly interoperable decentralized web. Now, consensus. So, when we talk about decentralized web and blockchain, there are multiple nodes that communicate or that are connected together in a peer-to-peer manner, and they create the whole network. So unlike centralized systems architecture, where we have a central authority that has the control over the the data and the states, right? So what happens in decentralized? They need to figure out which data is valid and which data is not valid. So they need to come to an agreement. Okay, so this data is valid and this data is not valid. So that agreement, that whole agreement is called consensus. And consensus is just an algorithm that is running on the network. So initially, Bitcoin, we had proof of work where multiple miners or validators. In the case of Polkadot and validators, in Bitcoin they have miners. So they try to solve a cryptographic process and try to create blocks in the network. Now, Ethereum initially also uses like proof of work as consensus, but as it is like very much power consuming, they shifted to the new consensus algorithm. It is called proof of stake. So in proof of stake, what happens is like we have multiple nodes, we have multiple miners or validators. In proof of stake, they stake their currency, they stake their token, and those validators are selected out of random. But they are not selected totally as random, but so different nodes take like different amount of currency. So the higher you stake, the higher will be the chances to get selected as a validator. So when a node is selected as a validator, it's responsibility to verify all the transactions in the block and like mine it or add it to the chain. So I'm just curious. I mean, we were talking about consensus, and yeah, it makes a lot of point to move forward. Ethereum from POW to POS started, and there's a few more advantages that we will talk about in the next upcoming slides. But just looking at this slide, there is your basic graph course, and I'm like, okay, I don't even know what these are, and I have no clue. Like, am I supposed to be scared of the course here? Not scared. So I think most of us have heard about proof of work and proof of stake. Grandpa might be a new word. So like we like validate blocks. but in forthcoming. That's it. So it's consensus. It makes agreement in blocks in chain rather than blocks. So what happens is the validator, let's say validator chain, so which chain is now like my main chain, like which chain am I going to add more blocks into it. So as soon as like the two-thirds of the validators they select or attach to one chain, that chain becomes the final chain. And the block, the network, it will keep producing blocks into that chain. So this is what verified. So we can also say that is mainly block finalized. Yes, it is on both sides. And yeah, Volcker actually does not use proper proof of stake to be honest. Like it uses a slightly different version of proof of stake, which is called nominated proof of stake. So in proof of stake, the validator who has like staked his or her token, they get selected, right? But in nominated proof of stake, only the nominated validator gets So this line, this arc, that is HPC, are what these are the frequency which manages and communicating with it. So at location there are private sites. So private what we talking about here. So private in every blockchain like this and orthodox blockchain private are two types. One are which we what is the main execution file, right? So how? So the question might arise: how are they managing multiple Rust projects inside a single template file? So Rust has a special feature of managing workspaces. You are using cargo workspaces. So if you see the main cargo on top, inside the individual runtime or node of Alice, you have your cargo in which you will import all your dependencies that is required for your cargo. For example, this is a runtime. This project is called name of project is known as runtime. However, when it comes to main directory, the source root directory, you have another cargo that refers to or stands procedural macro, and one more is an attribute macro. So what are macros? So macros, in a very question briefly, I can tell you that they are functional logics that take some parameters to execute and figure out in the backend. So now that is the same thing as a function. You ask me what's the difference between a function and a macro. So the main difference here is macro can run individually irrespective of the code logic that you're writing. Functions are mostly associated or methods that you write specifically for the logic or the business logic that you want to implement. Macros, on the other hand, are utility classes. Right? So how do you identify macros? So if people here in the audience have already worked on Rust, most of you must have seen this print statement. So in the print statement, what do you have? So your Rust print statement will have something like this, right? You have a print ln macro, ln stands for print line, and you have a exclamation mark, right? These are called as procedural macros. So this print line itself is a macro that basically takes two parameters. One is the statement and then the variables, right? They take these two parameters and it runs in the background in the Rust compiler and throws you a standard out. Standard out is nothing but writing out to your system term or any standard out. Right? So this is a procedural macro. When you come to attribute style macros, those will look something like this, where you have a hash and then you have the name of the macro. So these are also can also be characteristics, and these are also same thing as what a macro does, but these offer more ease of writing code when compared to your procedural macros. Simply because these can be outright used as decorators right above your function. You write a function, you attribute your function or decorate your function with the macro right on top of the code function line. So how does it work? I'll just do a small glimpse of it. So if you see, I am writing an enum error, and I wanted to make sure that this is valid error, right? So I just decorate this attribute macro on top of my enum that I'm writing, right? So automatically, Rust compiler understands that my enum error needs to have characteristics or run the logic that is implemented for this decorator or attribute macro error. So this is how it is used. Right? Now coming back to in substrate framework. Now how does it make life easier? Substrate already provides a minimum set of macros that we can use to develop our own custom code. So we don't have to go and fall in that of how to connect these pieces of functions that we're using to make it work on the blockchain and all that. No. So these are the certain main functions. So palette, like I said, palette, just assume it to be a library of such, and then you have config. What is config? Config is the definition of variables or constants that or types that you need for your palette or library to work or run. I'll just repeat this statement again. Config consists of the types, variables, and constants that is required for your library or palette to work. Right? And you have hooks. Hooks is basically like Rajat had mentioned earlier about states. Everything happens over time. It's an asynchronous call of updating a state. So you have hooks that can help you do that. And then you have a call. The call macro is basically the main transaction that you are going to, like I said, it's also called as extrinsic in the overall ecosystem. Basically, huge amounts of information. In blockchain, everything is encrypted and hashed using cryptographic algorithms. Right? We store a hash of the entire data into this storage. That is what file storage is. So using these certain minimum macros, we can easily build a palette. So that is what we are going to do today, and we'll make sure to write single functions by the end of the session. And this is a link that I want also to visit when you're starting palette development, because this link gives you all the different palettes. So apart from the palette that I spoke about, macros that I spoke about, there are many other macros that you can use. But what I spoke was just the minimum requirements that you need to have to build a palette, right? So like I said, there is a all of this, and you also have clear documentation of the storages that are being used and how to use them. If you see, each of these attribute macros are basically decorators that are on top of the function or structure or enum that you use. So that is how it is used. Right? Moving on. So coming back to our code base, right? Right now, I have a palette, and I told you there are macros. So this is the general structure of a macro. So coming back at the top, there is the first line that defines saying that this is a macro. Again, you have an exclamation mark. The moment you see exclamation mark, it has something to do with the macro, right? In Rust. And so here it says configure an attribute. So you configure an attribute, and the attribute is for feature STD, saying that so most of your blockchains run on no STD code. What is no STD and STD? You might get confused, but a simple way of putting it across is that STD consists of all your collections or your primitive types that you want for running your code, right? This is something that runs as a package when you install the code, install Rust or install Python or install Java or C into your system. It comes from there. It's a standard library that you have imported into your system or installed it. However, this standard library cannot be won't be available when you want to use it at the blockchain, right? So, so that is why we have to make sure that when we are writing code, we are not using any functions from the STD. And if we are using from the STD library, we want to make sure we announce that. So that is what we are doing here. Most of the code that is written here is no STD code. It is for feature STD, not STD, it's not STD. That is your first one. Coming down, you have this palette. These are basically import statements, as you can see. And Rust treats every other file in your source directory as a module, right? So we can write mock tests and integration tests for your palette for testing. However, this is beyond scope of the tutorial today or the workshop. And coming back, so this is your main point as palette. So here we define a new model, call it palette, and decorate it with the frame support palette attribute macro. Right? The moment we just do this, so all of this again, I'm following the lead that though I'm explaining this, you don't have to write all this. It's already there. All we need to do is just fill up our own custom things inside all of this. But I'm just giving a brief of how to understand this file, understand the withdrawal aspect. So coming back, you see inside the palette you have import statements. Now you can have a good question. I have import statements here. I have import statements here. So the only difference is that this scope of import statements for line 19 and 20 are strictly within the module palette, while these import statements are for the entire package scope, right? So the main library scope. And coming on, we found the first palette, so we are just defining a struct called palette. So Rust does not implement hooks programming. It has something called as traits and structs that are being used to replicate or use such features of hooks, right? So basically, for it very briefly, it's not, I wouldn't say it's the right translation, but you can assume a struct or the name of the struct to act like a class name, and the functions inside the struct to be the class methods. Now, if there's an animal class, I will have a just an animal struct, and needs to implement that config as well. So this is how the connection is happening between the blockchain and to your wallet. So as a developer, you don't need to come and worry about, oh, how am I going to connect this function to the chain and all that. This is all taken care of just by this one line. And here we design all the different basically types or parameters that we use. So once you're seeing the runtime event, like I said, Volcanon uses web and event-driven system to communicate or communicate all the transactions that are happening. It can be success, it can be failure, it can be error, it can be pending, or all these kind of things, right? There's just a handler to go to handle all the events that need to be thrown at runtime. Coming on to storage macro, like I said, you have a dedicated blockchain storage. There are different types of storages that you can use. So mainly there are three different types of storages. One is a storage value. Storage value is basically one that stores a single value. For example, I want to store 1, 2, or just a single variable or constant that you want to put it into your storage. That is when you use storage value. Then you have something called storage double map storage map. Storage map is nothing but key value path storage. It's similar to your map functions in Rust or in Java, whatever it is. And if you are coming from Python, it's similar to your HTML, right? And moving on, you also have something called storage double map. Now, what is double map? It's nothing but map is a single key, single value. Double map is double key, single value. Means you have two keys and a single value to store the data or access the data. And you also have something called storage nmap. Now, what is storage nmap? Nmap is you can have multiple keys. Now, you can have n number of keys. Now, I want 3 keys for a single value. I can do that using storage nmap. You want 10 keys for a single value, you can do that. So, more on that, like I said, please visit this link that I shared in the slide. You can come here and you can find here. So, you can find all the storage maps and all the details of the storage that are being used in subject. Right? You have storage value that stores a single value, then storage map, storage double map, and you also have storage nmap. Coming back, so this is about the storage. This is how you do. So this is where to name your storage. So something is a variable name that you can change based on what you want to hold, and you can store it into the and you can store your values into this storage. And the function, if you see this declarative here, this is getter. Getter is nothing but implementing a get function for your storage. So using function something, the name of something, I can access the values in my storage. That is just a setter and getter. The concept of setters and getters, this is just a getter. Coming back to events, like we said earlier, events are basically all the data that are thrown after transaction. It's not returned. A transaction doesn't return the data back to the requester and from where it came from. In turn, it throws an event into the web socket exchange, right? So this is the name of the event. So we have something in the storage. I stored something into the storage as a transaction, and I'm going to do an event saying that something was stored. And what is that something? It was the value of 232. Like 232 just a fact, right? It can be a number, unsigned integer of 32 bits, right? And who stored that? In the Web3 world, all of us don't have names. More importantly, we are worried about our account IDs. Account IDs is your identity on a blockchain, on any blockchain. So that is what it is. So we are throwing an event saying that somebody stored this value into the storage in my wallet, and this event will be thrown based on your wallet name. We shall look at that in a minute. And coming back to error, what is error? Error is all the error names that can occur. For example, I have a storage that is I have written I am using storage value which takes only 200. 200 was only 32 bytes. So what happens when it goes beyond the max value of 200? Or what happens if somebody goes below the min value of 200? It's going to throw an error, right? Because there is not a space to do that, or you can't do that. So that is when what happens is you have an error called storage overflow. When it goes beyond the max, your storage is overflow. You cannot store anything more, right? So those kind of errors are such examples. You define it here, well, and yeah, that's again declarative parameter. Now, coming back to the call, like, hope you remember the call. So, call stands directly to call. You just call somebody on your phone with the phone number, right? To make a transaction on the blockchain, you just call this function name. So here the function name is do something in the template. You call do something. What do something does? It takes a parameter called something, some other value, and it puts that something. So the code is very simple. When you see only this piece of code, it takes a parameter, a value that you want to store into the storage, and it makes sure that the person who's calling ensures signed means an account ID has authorized his account to make a transaction on this particular blockchain that we are communicating with. So once it is signed, you get the account ID here. Who is of type account ID? As you can see, the annotation for account ID is showing up here, right? And then you access the storage. Something is the name of the storage here, right? We are using the method to insert the value into the storage. So we put the value that we took as a parameter something, and at the end of the transaction, what do? We just throw an event. So self deposit event. Deposit event is a function that your code automatically provides, which throws the event from your event enum. So event is the name of the enum that you have here, and then you're accessing the something stored name or the event that you're storing, and you're passing the data along with it. So this will be thrown into the stream of data, right? And this is cost development, right? So this is going to throw an error message. So let's just have a look at how this works. Now, how do I execute this code? This is a template code. I have not written any of my logic or any new code. We'll just run it as it is and see how this works. So cargo will is the command that you use to run your project, right? And this will take some time. So moving on, I just want to show you how can one interact with the backend. So most of you, I have just shown all of this is backend. So there is something called as the Ultra.js Explorer. So it's basically your block explorer. Each blockchain provides you a block explorer. For example, in Ethereum you have Etherscan. In Solana you have their own Solana block explorer. Similarly, you have in Polkadot block explorer. And here you need to connect to my local node because I'm running it locally right now. It's still building, but yeah. While it's still building, let me just show you on so basically what I'm telling you guys is how to get started on developing on the Polkadot blockchain, right? So something that can help you furthermore from directly coming into and importing your code is coming to substrate.io or substrate.dev. They have a dedicated page where you have a bunch of tutorials for people to work on. Like you can come here. There are a lot of documentation which is in Polkadot. There is there is a little bit of intro to what is Polkadot, what is blockchain, and you have several tutorials as well, so that you can go through, right? See, for example, palette design using macros in a custom palette, right? These are all tutorials that you can go through and something that you can do on your own. There are almost a set of 30 different tutorials that a beginner can come here and do all the tutorials here. And once you complete all of these tutorials, you're almost like, so if you see this tutorial system, it's pretty simple. It's just you install whatever requirements, basically your Rust, your entire environment, you do the build, you do a test, and then these are the tutorials that you can go through to get a little bit of hands-on or intro into how to build your custom blockchain, right? And Palace, like I said, is the custom blockchain logic that we write as libraries, small libraries. And for those of you who are interested to build smart contracts, Polkadot provides you something called as the Ink programming language. Ink is a framework that is based off of Rust only again, and you can build smart contracts. So what is the a good question that I expect people to ask me at the end of the session is, you have two different frameworks that Polkadot offers unlike other blockchains. Now, what do I use when and where? So I can give you the answer, but I hope some of you from the audience can tell me when you think you use a smart contract and when do you think you want to build your own blockchain, right? We'll just wait for that in the next session. And yeah, coming back, we have how to connect to the relation, how to connect to the parachain, how to acquire a distance log, how to create your own message passing channels. Like I said, out of the box, Polkadot offers you with technology that can communicate between two parachains or all the nodes in your network or the participants of the relay chain, right? So we have XCMP, like I said, is a gross consensus messaging passing protocol, which lets you pass many messages. Then you have DNP, you have UNP. These are all protocols. Protocols are just set of rules that you need to follow to establish the functionality that is being provided for you guys. Right. Hopefully the code is built. So yeah, the code is built. Now how do I start the code? Now I just want to demo it for you guys. This so once the code is built, it's saved in your target folder. And we have node template is the name of the node that I'm running right now. How do I get this name? If you see, come back to calculator terminal. Here you can find the binary execute name as node template. Right? And then I do dev because I'm not dev environment. WS stands for WebSocket external. This flag lets this node communicate with the external call, saying that I will allow other people to come and pull data from my stream. Right? So the node is starting. You can see that the node has started. There's a version substrate develop. There's a name for the node. It's called blockchain drawer 2106. There's an authority. There's a database. There's clock series and ability that is storing all of your blockchain data. You have Grandpa, which is the final authority for your block finalization. There is a Genesis block that was created. This is the hash of the Genesis block. You have this main header hash. That is the hash. And you have just some details around that. And then you can see now because I added the dev flag, the blocks are being finalized. As you can see, it is prepared block number 6, block number 7 is progressing. Had I not used the dev flag, the blocks will not finalize until I have a validator who finalizes the block for me. Right? So just for development sake, Volcker has given you the dev flag where block finalization can happen automatically. Now blocks are happening. Now how do I interact with this blockchain? It's a node. A small node is running in my background. So if you see, I am connected to my local node, which runs on this port 9944, which is a WebSocket connection. So like you can see, HTTP is a protocol for API calling or web-based calling. Same way, WebSocket, like I said, is another protocol. We have the port number 9944 where our node is connected. Right now you can see the same data that you are seeing in my terminal. You are able to find that these blocks have been created. This is a block explorer. As of now, there are 16 blocks that are created. The block time for each block in Polkadot is 6 seconds. So within 6 seconds, the new block will get generated. You have an event section where you can see that all the events. Coming back to the accounts, so if you see here accounts, these are all the default accounts that the development environment provides you for you to test, maybe transfer of money or do transactions, update storages, all those kind of stuff. You can see that these are of type SR2519. SR2519 is nothing but a encryption algorithm for public addresses. For private addresses, the counterpart is ED25519. So you know an account in blockchain is a key pair. It's always a pair of account addresses. One will be public, one will be private. The one that you see here, the 5 series, is your public address, and the algorithm or the encryption algorithm used to do this is SR2559. And when it comes to private, it's ED2559, and we cannot see that because it's private. But yeah. But most of you guys dealt with wallets and all that, you must have known about the mnemonic words that are being used, right? There'll be like a 12-word mnemonic that is generated for you, and you store that in your account, and that is basically a recovery trace. So that mnemonic in turn uses ED25519 encryption to give you the private address in Polkadot. This is strictly the Polkadot that I'm talking to. And you can find the balance. Now balance has this much amount of tokens, M unit token in her account. And if you want to make a transaction, you want to send some money from Alice to Kali, you can do it via the block explorer. So if you just want to try that, I can send from Alice to say somebody who's broke. See, Eve is totally broke, right? She has 0. So let's send some money to Eve. So I can just put it up. So Polkadot has a 12 decimal account. So we have units here. It goes up to iota price, so it's just 10 bar minus and all that. So say let's transfer about 1000 tokens to Eve. And if you see here, it says, are you sure you want to do it? Are you confident? Are you excited? Stuff explorer, you can find that the transfer happened. So balances is the name of the palette. You guys remember when I showed you runtime lib.ls, and in cluster runtime, I spoke to you about balances here, right? This is the name of the palette. Palette balances is here abundant on the Pulsar ecosystem, right? And this is the one that is responsible for making your transfers and all that. So from Alice to Eve, amount of 1,000. See, like I said, there are so many trailing zeros, right? After 1,000. Basically, the subset node template by default comes at the decimal value of 10 bar 12. So if you see, to get 1,000 units, there will be 12 decimal zeros. There are 12 decimal units to fill. So 3, 4, 3, 6, 8, 12, right? That's what it is. And balance control is another event that basically an account was created with some free balance. These are the events. Like I said, it was a transaction. Transfer of money was a transaction. And in turn, I did not get data, but in turn, events were thrown into the socket. And if you read here, it says 40 to 4. So basically, this transaction happened in the block number 42, and this was index number 3. So this was event that number 3 that happened, or transaction number 3 that happened in block number 42. And in block number 42, and event number 4 was thrown saying that the transfer succeeded. So this is a small view of how to use the explorer, and also we want to use the extensions that we call, right? So if you come here, this is the developer tab. You come to extensions. You have something called as the system, and this is basically all the name of the palettes that you have defined at your runtime. Like I said, this is the same thing: system, random continuous function, or random balance, pseudo template module, right? So this is the same thing as what you can see here. These are all the functionalities that you can use at your runtime. So now let's use the template code. First, we do something. So something, what does do something do? It takes a value. Now say I want to put number 7 into the storage. I take a value. I'm going as representing Alice here. And when I do that, I want to put this transaction. Again, you get this window for sign and send. Yes, you submit the transaction. Now you see it's loading. Template module is the name of the palette. Do something was in block, and then this succeeded. Balance was withdrawn. Why was balance withdrawn? Because every Alice had to pay transaction fees or this transaction. Right? If you go to the Explorer, template module is the name of the palette, and something stored. The event that you had seen here in your palette is Alice. Something stored with the value and the who, right? So if you see here, something stored, the something was 7, value 7, and who stored that was Alice, right? This is an event. Now, I also want to show you where this storage is. So to do that in Explorer, you have to develop a change state. You come here, and then you look at the change state, and then you can see that there are, again, you have names of palettes, Aura palettes, Grandpa, and all that, right? I want to go to my palette template. You have palette version and something. Something is the name of the storage. This is similar to what we did, what I showed you here. This is the name of the storage something, right? In something, it is an option of user. So this is Rust basically. Option means it can have a value. If it doesn't have, it goes none as a value. So let's query it. If you see right now, there is a value of 7 that is stored in the storage, blockchain store. So this is basically how you start getting getting introduced to something and start developing. And now you must know, you don't need to know anything about the code. You just come, clone the repo, set up your development environment, and then start running, and you should be ready to go. Right? So as of now, you have some regular software that just does do something for you. Right? Now let's modify this code. If I were to modify this code and say I want to do something a bit different, like now something that's trending in the blockchain ecosystem is NFTs, right? I want to showcase some kind of doing NFTs in my code, right? All I have to do is, it's very simple. First and foremost, if you want parameters at the config level, you can add parameters here, but we are not doing that now. I just want this session to be very beginner friendly. Tejas, on the other hand, my colleague, in the afternoon session will be taking you in depth of palette development, line by line and code line. So this is just a small intro to how to do that. So again, all you need to do is write your functions. So that is what I'm going to do now. I want to create a NFT class basically in OOPS. Here I'm going to create a struct, and then I'm going to create a mint function that mints an NFT. What is minting an NFT? Is nothing but creating an NFT. Let's quickly do that. So to begin with, I want to initialize a struct which has the NFT info, right? So in NFT info, I want to have certain fields. The name. The name is a vector of UA. Now, a good question here would be, why is name vector of UA is supposed to be of type string, right? But on the blockchain, like we said, string is a data structure. Most of you have misinterpreted this analogy while coding. If you are beginners and if you're seniors, you already know what a string is. It's a data structure. It is not a ready-made variable entity or a type that is there. So it is a data system which contains characters, right? Which is basically a byte data. So to the code, so for the machine to understand, it's all bytes. It can only understand the bytes, right? So vector is basically a dynamic array. That is the short form for vector. And you can assume this as an array that you just keep adding data to. And UA is the type of data. So your bytes is of type UA, and that in turn converts your string. The byte stream of data has a message that is embedded into it, right? That's why name is a vector of UA. Similarly, we'll just write some metadata. What is metadata here? NFT can be stored onto storage services like NFT storage or Pinata or OpenSea somewhere, right? You want to store the link of that to that. So that is again a string. So for anything on a string, I on Mahindra we write as vector of UA, and then I want to add some ID to my NFT. So I just add the ID field, right? Now there are certain things that we want to annotate this structure when I'm developing a Holger. So certain things are some derived functions. So again, derived is an attribute mapper where you add characteristics that you want for your code basically. So I want to have my struct NFT to be able to be cloned. I wanted to have encoding capabilities. I wanted to have decoding capabilities. So these are all traits. Encode, decode, clone are all traits or characteristics that your type can have. I wanted to have implement partial equalization. So partial eq is nothing but that is simple. Then I want to have runtime debug just in case I want to print some data onto the terminal. And I also want to have type info. So more on type info, just a translation layer for maintaining types when communicating with the external body, right? Because Rust is strictly type driven. And similarly, I want to add another safety feature. It says scale info. The scale info is basically your scale is your translation layer that handles encoding and decoding for all your types. That's a basic, and then I do skip type patterns. So skip type patterns of type tree. So Rust has this concept of generics, and everywhere you find, I will be showing you the generic parameter t right now. So I'm not using t here. So if I were using t, and then I want to make sure that while decoding this data or serializing or deserializing this data, when sending it back to an external client who is requested or made a call to, I want to make sure that you remove this type parameter t and you just deserialize the data and you send it back. So that is what that is doing. So now I have an NFT info which has a name, metadata, basically a link to the NFT file, and then you have an ID that you want to store, right? And then I want to store this on my storage, right? Now first and foremost, let us change this. So all I want people to just follow on how to modify your template to do something of your own interest. Please don't look at the complexity of how much this involves, but just try to understand how simple and easy it is for you to do stuff. So I just changed the getter function name. I want to call it NFT store, right? And I want to call this the NFT store again. So this is the name of my storage, and here you have this type parameter t. I want to pass t here, saying that t is of type which implements the config trait. Config trait is this. So I want this t, this storage, to implement storage of type t to implement this configuration, so that I variables from the config. And now I don't want to use the storage value. I have demoed it. Let us use a storage map. Right now, storage map has a certain syntax. Now, first thing is just def would say underscore of sorts. And the second parameter that you pass is the encryption algorithm. So there are multiple encryption algorithms that Router provides you that you can use for encrypting your data. There is 264-get, there is Blake, there is MD. There are so many algorithms. So we today use Blake. So we'll use Blake to 128, just hoping that the data is not too long. And then you define the key. Storage map is a key value data structure, right? So I want key to be my account ID. So account ID, and then I want the value to be my NFT info struct that I created. And I also add it as an option query. So I am going to add it as an option query reason because if the storage is empty, it will return or none. It will not return. So if I do this as a value query or leave it empty by default, which is a value query, it will return the default implementation for the key. Account ID does not have a default implementation. For example, for U32, the default of U32 is 0. That is the default. But account ID is a custom type. Now a good question to look at here is I am using the syntax of key : account ID. Here I said my entity store needs to implement the config that is implementing. So it implements the frame system config. Frame system in config in turn implements this account ID type. And where can I find this account ID that is implemented? Right? If you see, okay, no, this is the end number. But if you see at your runtime, if I search for this, yeah. So you can see account ID line number 69. A type account ID has been created with the runtime wait.us. So this account ID is what I'm importing into my storage, saying this is going to be my key, and this is my value here. I'm storing my value here. And now let's change this as NFT is stored, right? And then we want to throw the name of the NFT. NFT name is again a member of wait, and the owner of the NFT. Right? So these are the few things that I want to do. Errors, we just leave it as it is. Storage overflow and that thing. Let's remove this whole thing. We don't want this function. And let's rename this function. So if you see, your call is also attributed with something called as wait. Remember I told you that each of the transactions has something called as transaction fees that are being charged for every single transaction that you make. Right? This is the handler for maintaining that. So you have certain fees that you can specify here, or you can write benchmarking tests to benchmark how much actually is the transaction fee that based on the read and writes to the database. Each read and write is can be charged, right? Based on that, the benchmarking will calculate the transaction fees and will do that. So that is a valid way in the macro to do that. Now let's change this as new tenancy, right? And in terms of the things that I want to use, let's first take the name. So wait, and then we have which is again a vector of wait. And lastly, I want an ID, right? So these are the things that I want. And then here I just know the sender, whoever is caller or whatever it is. Sender is the account ID that I will get, right? The owner of the person who wants to mint this NFT. And then here I change my storage saying that is NFT storage. Yeah, so NFT store. Now I have just gotten the account ID. So sender has the account ID of the person who's calling. Now I just need to create the struct for the new NFT that is being sent. So let new NFT is equal to NFT info. Name of the NFT will be this. But I want to clone the variable because I want to throw it in my event. So in Rust you have this. I'm pretty sure you guys must have heard of pointers or in the previous questions. You guys must have heard of pointers. So once a variable is closed, it's no longer there in the variable. It's no longer there in the memory. The same thing goes for rust. Once it's closed, it's not there. So to make sure that I don't lose the data in my memory, I clone the data in that particular memory. I want to use this because I'm going to use the same throwing an event again, right? And then I want to store the metadata. I just leave it as it is, and then ID. These are the three things that I want to do. And then I update my storage, NFT store, and I insert. So insert the functionality. The key, like I said, was the account ID, right? The key is the sender, and then I want to insert my URL. So this by now, so what I did, I created a new NFT struct. I took all these details from the person who's calling this transaction, and I'm storing that details into this storage. And now at the end of the transaction, I want to deposit an event. So we have NFT stored event, right? NFT stored, and in NFT stored, we want the NFT name. NFT name is same as the name. So if you see, this is the reason why I cloned this, because I'm already using name here. It is out of my memory, so I can no longer use this name here. So that is why I'm cloning here. And what else do we have there? Owner. So owner is basically the sender. Okay. This is the event. At the end, I dispatch a result. So result is a type that Rust provides you that returns either an OK or an error. OK means the transaction succeeded. An error, if it is, there is some error that's thrown, right? Now, everything looks pretty much this one. So again, I spotted one mistake. There is sender which I'm using here. This is sender was initialized here, and then it's being used here, and it's out of memory now. Again, I can't use it here. So before using it there, let me just clone it. Okay. Now doing this, and I do the cargo build from that. Okay, there are some errors. So it says max encoded length. So in blockchain, you have to always be careful that every time you're writing your code, any data that is being stored on your storage, the compiler must know at runtime what is the max length of or max storage size that variable can have. Right now, I don't want to dig too much in depth of it. Here, I just can add another attribute macro that says without the storage info. This will eliminate this error. So just telling, I'm just using a small macro to tell the compiler saying that you generate all the storage info without you even creating the, without you even loading the storage. It's fine, it can handle it. Something like that. There's another thing saying that vector is not found. So it's saying that vector is not found. We can import vector from wherever it is available. It says, so that's the thing. So it says inherit vector, right? Which we just imported here. Yeah. All the errors should be found. Yeah, it's compiling. So if you like, while it's compiling, as you see, it's very simple. All I didn't need to, yeah, I showed you a lot of macros that I used. I didn't have to define them and write them on my own. There's a template that is already there. All I need to just change the data that I want based on my business logic. I can change the file name, I can change the functionalities, I can change the call. It's as simple as that. So it's only going to be 10 minutes of work to write the first transaction on Polkadot using subject fallacy. And meanwhile, it's running. Let's have a look at how it's going to work. So yeah. The next session will have in-depth palette building. You will understand how to build a palette in depth, like line by line. Hopefully, all of you have got a basic idea of how to start off with the code as a small developer. And something that people might find hard is trying to understand Rust and its borrow sticker. Borrow sticker is the model that, like I said, the variables where I need to do its clone, else I will not have my variable. So these are certain concepts of traits, borrow sticker, pointers that one has to know as a prerequisite before coming into programming directly. Now let's just start the command, same command that I used previously. Start the node is started. Let's have a look at our Explorer. Yeah, it's connected now. So you can see the Explorer is running. Yeah, it's taken off from where it was previously. So now you can see the updated thing. So it's only block number 2. Now if I go to my config and I go to my palette template and see I have a mint NFT concept. I'm taking name, metadata and ID. So in name, say I want to mint a Batman token and link to the Batman token, link to Batman. I don't want to use symbols. Yeah. And say I want to store the ID of this token as 70. And I want to store this. I'm as an Alice. I'm submitting this transaction. This transaction was submitted. Let's have a look at it in Explorer. You can see template module stored NFT. The name of the NFT is Batman, and the owner is Alice. It is stored. This transaction is created at block number 8, and this is the second event that was thrown in block number 8. Now, if I want to look at the storage, again I come to developer, change state. Uh, Click on template module. There's an NFT store. This is the name of the storage that we wrote. And here I just want to check based on the owner, right? Here I can do it based on owner or based on just query the entire store. You can see the address here. The This is the account ID for Alice. So how do you know that this is the account ID for Alice? You can see at the end her account ID ends with AUEQY, right? That's her account ID. So Alice owns an NFT which has these NFT inputs: name, Batman, metadata, and your ID. So this is basically pretty much a small demo of how you get started with the Substrate ecosystem. There is Substrate.dev, which makes it more easier for you to start uh, getting yourself introduced to developing on the framework. And you also have a lot of documentation that you can read. And this is a small intro. This is where I would like to conclude this session. And a small intro to who we are. We are from Bhavlabs and Coder India. We also have our community called Coder India where we conduct workshops. We have so far completed 2 boot camps successfully over a period of 6 months where there were hundreds of engineers who enrolled assignments and were given. People complete the assignments, submit it, we verify it, give you feedback, and there are also job opportunities that happen. Apart from that, we also have something called the Dot Fridays where external, I mean, people come in and talk about their applications like Akala, RMRK, the NFT storage. All these applications that are built on Polkadot, they want to come and share their details. It's a community where you can find new startup owners, link, communicate, and a whole bigger community for developers to understand coding, have errors, coding errors in VDR diagrams. You find the link. This is just a small snippet of what some of the sessions that happened in September. It was all across India. It happened in Delhi, Chennai, Bangalore. It happened. It's a monthly event, and yeah, you can always subscribe to our community. There's a Discord, a dedicated Discord channel. Communication is key for a developer to enhance his skills. And yeah, Discord is one brilliant thing. You can scan this link and yeah, you can find the link to Polkadot India, Discord links. All of our links are available there. That's it from our end. Me and Rajat. Thank you guys. And we are open for Q&A now. So to start up the Q&A, like I said, I would like somebody from the audience to probably tell us when or why they want to use Substrate as a framework to build a custom blockchain or a smart contract.
All right. So first of all, huge round of applause, everyone.
Sneha, can we have
Okay, requesting the tech team to just check if we are audible to the speakers. In that
I think
case,
it's Rajesh.
Rajesh.
Yeah.
And also for all of you wanting to follow up this code, like I said, it's available on our Wow Labs organization repo. You can head over to GitHub Wow Labs. You will find IBC Hackathon workshop, and under that you will find the template. The workshop one is what I mean we do, and the code for NFT storage and minting is here. And yeah, you'll find all of the code here.
all right, Sneha, are we audible? Sir, can you hear our voice?
So that's it from our end, guys.
Yeah, guys, can you, the tech team, can you please check, Deepak, if our speaker is audible?
Rajesh, yeah.
Yeah, sir, can you hear us?
Yeah.
Yeah, all right. So, guys, a huge round of applause for our speakers. So, sir, actually, we already had a huge round of applause, and apparently our voice didn't go out. So it was quite a,
Yes.
the session was quite in depth, and I'm sure students would be eager to know more. Are there any questions? Anybody wants to ask anything? All right. So I think I have one question online. Is there a resource? Where are the resources available for palette development?
Like I said, is mainly your substrate.dev that you want to refer to whenever you are uh, starting node. Substrate.dev, you come into developers, you have playground, you have documentation. So come to docs. When you come into docs, the first and foremost thing is get started. You start with this get started place first, and then you keep moving on to all the tutorials. By the end of finishing all the tutorials, you should basically complete your basics of how to handle palettes and how to understand them and how to start building on them. Substrate.dev is a brilliant place. There is also Discord community for Polkadot India for Substrate technical channel. This is hosted by the Karki Tech, the founders. There is also Element chat that is available, and most mainly for people who are developing something that I think So something that will help is Substrate Stack Exchange. So you have substrate.stackexchange.com. I don't think everybody is able to see the screen, but hopefully you guys are able to screen. And this is a dedicated Stack Overflow kind of environment for you to ask questions on all the errors that you get. And all of us from our team are actively answering questions here, and we are also asking questions ourselves. So yeah, this is how you start getting started with it. Yeah. There are plenty of tutorial videos on YouTube from the Karate team as well, and yeah, you should be able to start off from the tutorials. And this is pretty much good base to start.
That's nice. I'll take this up once again. Yeah, okay, we have a question.
Sir, actually, in the session, you asked us a question, right? That when you use a smart contract and when do you want to use a blockchain?
Yes.
I'm also curious about that answer. Actually, I was thinking something about that.
So do you have any needs on when you want to build your own blockchain? As in, like, see, your smart contract is your own the application of your own choice. But what is the difference when you want to build it as your own framework or your own big logic with a lot of configuration and all that, in comparison to smart contract development that is very limited? Like, you just need to have small contracts that you need to fill up and you do it and deploy. When do you use this? Like, think along those lines. When do you want something more specific?
Okay, thank you.
So yeah, coming back to that. So basically, the answer is when you want to build a big architecture of sorts, a big blockchain architecture that involves a lot of decision-making algorithms, a lot of functionalities that need to be modular. In a single smart contract, how many functions will you write? Yes, you can even arguably say that I will write multiple smart contracts. But talking to smart contracts, again, you need to make sure you're writing the integration level for talking between smart contracts. You should have a clear architecture of how to talk between smart contracts. And as of today's architecture level, there is no clear, production level architecture that lets you do multi-contract development and also architect it in such a manner that it is modular, safe to communicate, you're handling all the security issues. But so these are the places where I would choose to build my own blockchain. I'll use Substrate to build my config, and like I said, Substrate frame system config in the code that I showed implements all the things that is required for you to connect all the different nodes or files together, right? You can have different functionalities and you custom write everything. You can build it from scratch. So maybe smart contracts let you do only, like, there are limitations to smart contract and a variety of functions and storages and things that you can implement. So your limitations is removed. So these use cases come in handy when say I want to build a huge NFT marketplace along with a Unity framework that has game development. Metaverse is the trending thing right now, right? I want to build a metaverse that has complete cryptocurrency with it. It has some NFTs. These metaverses have lands. I want to buy lands in NFTs. I want to have avatars, and all of this want to go into a decentralized economy. Basically, I don't want to trust decentralized organizations. For such use cases, it's so huge, and you want to build an entire architecture around it. These are some scenarios I would use using my own custom blockchain. So many people out there are doing that. They are building their own chain for this. You have Decentraland, the famous metaverse that is doing that. So this comes to gaming. So on the other hand, you have decentralized exchange that lets you list cryptocurrencies and have a or list and buy cryptocurrencies, right? So again, these decentralized finance applications, depending on how far you're implementing functions, it can have staking, it can have bonding, it can have governance, it can have rewards back for you, and you can also have liquidity pools where you want to write your custom logic in the liquidity pool. Basically, when the liquidity matures, you ability to participating in the functions, right? So basically, it removes the limitations that you have that smart contracts have, and you can architect your code in a much better manner that is maintainable, readable, and future proof. I hope everybody understood that.
Yes, sir. So thank you for clarifying that doubt. And anyone has any other question right now? I guess not. So guys, a huge round of applause once again to our speakers for taking out the time, and to Polka.India also. Thank you so much, sir. It was really lovely to have you, and I'm sure the student had a lot to take away from those sessions.
Thank you guys.
Thank you, Rajat sir. Thank you, Lokesh sir. 45, 46, 47, 48, 49, 50, 51. You're 51. Come on, man, don't do this. 52, 53, 54. All right, so what I'm going to do is basically, according to your numbers, all right, I'll ask it once again. Anyone here who doesn't have internet or doesn't have the number, hasn't got a number? Okay, till what number did we reach? 54, okay, so you're 55, you're 56. Anyone else left? 57, ma'am. Yeah, put your hands up. 58, 59, 60, 61, red, 62. Who else? Remember your numbers, who else? Okay, we are done. So starting number one, just keep a watch. One will go, sort his internet. Then once he's back, number two will go. All right? Am I making sense? One by one, no commotion, no sound. Okay, we are trying to manage multiple things here. We are making sure that everybody here has internet. So let's do it in a very much peaceful and quiet manner. Once all the numbers are done, the person who does not have a number, they can go and get their internet sorted. Make sense? We'll make it peaceful, right? And simple. All right, so we'll begin with the session. Students are here. Yeah, so number one has gone over there. Guys, Rajesh, the students are coming with their numbers. Who was number one? Yeah, start reaching out slowly, okay? And everybody else, no other student will be there in the backside, okay? Just the numbers will go. Make sure you are the second number, the person who follows are going according to their numbers. We want to make this happen in a most convenient and sorted way possible. All right, so now we will start with another technical session on building in Polkadot ecosystem. And for that, guys, please settle in. Yeah, okay. Excuse me, ma'am. Okay, fine. They're with us. Okay, we still, okay, fine. Let us give this another 10-15 seconds. I think some students are still. Anybody who can hear me in the lobby, please join us inside quickly in the next 10 seconds. Okay. All right, I see our speaker waiting to address you all, and so we should begin right away. Guys, please settle in quickly. Please settle in quickly. Right, so today we have with us Mr. Tejas Vijay. He will be here guiding you all, interacting with you all, helping you all build, right? I understand with respect to internet, there are some issues, but be supportive to each other. Those who have the internet, make sure the person next to you who does not have it gets the help, okay? We have to be cooperative because we want to make it a success for not just for us, but for each other. That's how we will basically, that's how we want to proceed. So Mr. Tejas is basically a software developer. He is quite young, if you can see. So it's not going to be a very serious session or something. I mean, when I say he's quite young, don't take it in a different context. Please take it in a very simple context. All right, so keeping time in check, I do not want to take any more moment from Mr. Tejas. And guys, yeah, so please give a huge round of applause for Mr. Tejas, the young engineer.
Hello. Thank you so much, all of you, for welcoming me. And thank you so much for the amazing introduction, Deepak. I see a lot of young people here who are interested in Web3, but I'm actually quite curious that, I really want to ask this question to, all of you, that what brought you to Web3, or what encouraged you to, come to Web3 and at least try out the technology?
Guys, you can raise your hands.
Raise your hands, bindas. इधर कोई judge नहीं करने वाला है किसी को. So just raise your hands, say what you feel, and no holds barred. All right?
I think they have eaten Tejas, so they might be a little slow right now. We'll have to warm them up.
Sure.
Who wants to be a developer? Raise your hand.
Who wants to be a developer?
Who wants to be a Web3 developer, basically? Everybody else doesn't want to be. Guys, raise your hands if you want to be a Web3 developer. Please.
Super.
Everyone, okay. Why do you want to be? There would be okay. Why are we putting the hands?
Yes, the why is very important.
Yeah, let's talk about it.
Shiba Inu.
Oh, okay.
Yeah. That's why I'm
Cool. What about that?
I just want to make money. A lot of it.
Fair enough. Everybody wants to make money.
Yeah, that's it.
Only money.
Yeah.
Super. Awesome.
I think that resonates with a lot of people here. So Tejas, you have your answer in the majority, but I saw some other hands as well. Anybody else wants to take that up? Or the hands that are down, so basically they also wanted it for the money.
Okay, so I'll clarify one thing, that I'm also into it for the same thing. So thank you. Cool. So how many of you all have, I presume that all of you are CS grads, right? Can I have nods? Yes. Okay, a raise of hands. Okay, fine. Cool. So the follow-up question would be, how many of you guys have, or folks have, coded in Rust? तो पिछला सेशन में क्या समझ में आया? All right. But I think you all have some experience with low-level technology, right? Like C or C++. Correct? So Rust is also in the same field. Just the syntax is different. And what makes Rust different from C++ or C is the ownership model that Rust follows. So, when you get hands-on with Rust and understand the ownership model really well, so you're bound to make less mistakes, or the compiler will be always on top of you to make sure that you write good code, right? So that's what makes Rust different compared to the other low-level programming languages like C and C++. But C and C++ se bhi koi ye nahi hai, problem nahi hai, they are also good languages. Cool. So what I'll be doing today, I'll be taking a substrate enhancement. Yaar, theek hai. So I'll be actually going through the basics of substrate again, letting you know how the palette is built, what are the initial ingredients that you need for a palette, and what you can do with substrate. Right? Substrate is basically a framework, or you can think of it as an SDK, which is used to build blockchains directly. So as you can see, if you recollect from the previous presentation, you saw that big circle, right? Big circle, right? So that is called a relay chain. Relay chain matlab the main chain. Okay, it's like buzzwords. So under those relay chains, you have para chains or sub chains. So that's how Substrate makes the environment interoperable. Okay, so like under Substrate, or sorry, under Polkadot, there are like multiple of these chains, more than 100. So multiple of these chains which communicate with each other using a protocol called XCM. But utna gehrai mein nahi jate. You just try and understand that Substrate or Polkadot is a very different chain from Ethereum or Bitcoin, right? Because in Ethereum, you cannot have interoperability with another chain. So that's what Substrate aims to provide ultimately. Cool? Yeah, I want to hear. समझ में नहीं आ रहा है. All right. So I'll be taking you through the Substrate palette again. We'll have a workflow. Okay, we'll write some functions. I'll code with you. मेरे को अकेले code करने में मजा नहीं आता. I don't like to code alone because my logic always fails. So I need some guidance in coding. So if you all are with me, super. Okay? Give a round of applause for you guys. Super. All right.
I think I have done that.
Yeah, so once he starts, just make sure the people next to you who do not have access as of now also get to see it while you're doing it. You know what we should do until then? There was a statement that was chanted yesterday. What was that? Anybody remembers? When you did that with Abhishek sir, it started with I want to. Anybody wants to complete that statement? I want to.
I want to what?
Yesterday, Abhishek sir chanted something along with you guys. Yeah, I want to.
No, I want to be an Web3 developer.
There was another word instead of Web3. Anybody remembers that?
Polkadot developer.
Exactly. So let's hear it at 1, 2, 3. 1, 2, 3. I want to be. I want to be. I want to be. Perfect. You'll be in few minutes. Sir, let's not speak about internet. Yeah, so we'll be hearing from Sai Ram Reddy. Sir, you want to come, dear videographer? If you want to come, you can come. Is there a wire limitation? Okay, so maybe you want to stand up? Is that okay? Thank you, thank you. Guys, please welcome him. He has been. No. No, let's not force him. No, it's okay. It's totally up to you if you want to go in front or you want to be here.
My name is Sai Ram Reddy. I am singing Komuram Bimodo song from Triple R. భీమా నిన్ను గన్న నేల తల్లి ఊపిరి పోసిన సెట్టోసేమా పేరు పెట్టిన గోండు జాతి నీతో మాట్లాడుతుర్రా వినబడుతుందా కొమురం భీముడో కొమరం భీముడో కొర్రాసు నెగడోలే మండాలి కొడుకో కొమరం భీముడో రగరాగ సూర్యుడై రగలాలి కొడుకో కాల్మొక్త బాంచేనని వంగితోగాల కారడవి తల్లికి పుట్టానట్టేరో జులుము గద్దెకు తలను వంచితోగాల జుడుము తల్లి పేగున పెరగానట్టేరో కొమురం భీముడో కొర్రాసు నెగడోలే మండాలి కొడుకో శర్మ మొలిసే దెబ్బకు అప్పంతోగాల సినికే రక్తము చూసి సెరిగితోగాల గుబులేసి కన్నీరు వణికితోగాల భూతల్లి సనుబాలు తాగానట్టేరో కొమురం భీముడో కొర్రాసు నెగడోలే మండాలి కొడుకో థ్యాంక్ యూ
Guys, show some energy at least in clapping, yeah? We have amazing people in our audience, and I'm really glad to be here amidst you, because now I think everybody would feel that we are in a very happening place at this IBC Media Hackfest. Would I be right? Really? Only 5 people think so? Would I be right? Is this a happening place? Let's see. There's more. I don't want you all to leave. Trust me. Guys, next we have Soumya. Give her a huge round of applause.
అటు నువ్వే ఇటు నువ్వే మనసెటు చూస్తే అటు నువ్వే ఏం చేస్తున్నా ప్రతి చోట నువ్వే అటు నువ్వే ఇటు నువ్వే మనసెటు చూస్తే అటు నువ్వే ఎటు వెళుతున్నా ఏం చేస్తున్నా ప్రతి చోట నువ్వే అప్పుడో ఎప్పుడో ఎప్పుడైనా నా చిరునవ్వే నీ వలన తెలియని లోకం తీర్పిని నాకు రుచి చూపావులే పరిచయమంతా గతమేనా గురుతుకు రానా క్షణమైనా ఎదురుగా ఉన్న నిజమే కానీ కలయ్యావులే అటు నువ్వే ఇటు నువ్వే మనసెటు చూస్తే అటు నువ్వే ఎటు వెళుతున్నా ఏం చేస్తున్నా ప్రతి చోట నువ్వే రంగు రూపమంటూ లేనిది ప్రేమ చుట్టూ శూన్యమల్లే నిన్ను చూపిస్తూ ఉంది. థ్యాంక్ యూ.
Guys, once again, give it up for Soumya. Thank you, Soumya. Thank you, everyone. I think that was amazing. I'll just let this place be silent now so that, you guys can get serious again. I don't think you'll start taking the session seriously otherwise. No? Right? No? Anybody else wants to sing? Do you want them to come up front now? Yeah? Can I see the hand? Arey, don't worry about coming up front. It's the same thing, right? Come on, we'll prep you up for Hackfest, Hackathon, and Indian Idol. Yeah. Aruna has joined us. Guys, let's welcome her. Guys, see, there has to be some team spirit, right? I mean, this is happening for you, right? A person who is singing here is, showing that courage to sing for you. So I don't want half or some people taking part in it. Let's all clap. Let's all welcome the person who is, showing us the courage. Yeah, thank you.
Hi, all. Hello. My name is Aruna. I'm from Mallareddy. రేలారే నీళ్ళల్లో నిప్పల్లే వచ్చింది నిజమల్లే పడి లేచి నిలిచే రణములో నా తెలంగాణ లేచి నిలిచి గెలిచే రణములో ఓ రేలారే నీళ్ళల్లో నిప్పల్లే వచ్చింది నిజమల్లే పడి లేచి నిలిచే రణములో నా తెలంగాణ లేచి నిలిచి గెలిచే రణములో సింగిడి లంగుల పూల ఇది జానపదాల మాల కొట్లాటలు నేర్పిన నేల ఓ ఓ రేలారే పల్లె మట్టి వాసనలే అందమైన మనుషులే బంగారు భూమి జగములో నా తెలంగాణ అందమైన భూమి జగములో థ్యాంక్ యూ.
Give it up nicely. Thank you. Guys, before we move further, I don't want to end this day with singing. Huh? Let me just check the status and get back to you. Give me a moment. Let's be patient. I see there's a certain. You want to sing? Yes. I can't. She doesn't want to sing. Yeah, so let me just check with my tech team if we are ready to play a song and then at the same time we can do some dance. Right, I saw some hands. Yeah, perfect, awesome. Let me just get back. All right, guys, do we want to see the person on stage for the dance? Come on, guys, clap! Come on. And just a small input. This was a suggestion by my friend slash colleague, Mr. Rajesh. So if I took up this question, then you maybe want to give a clap for him as well. You want to dance, right? Yeah. Okay, we'll just go and sort out the music. Guys, we are fixing the audio. Let's hear it again for perfect. Yeah, give us 10 seconds. You want to say something? All right. That was amazing. That was incredible.
Okay, good afternoon, ladies and gentlemen. I have an announcement to make. So we have all your development environment set up in the pen drives. So I'm going to pass it on. So you will find one zip file in it. Just copy it and paste it onto your machine, and then pass it to the next person. Okay? Right? And that zip file, you need to extract it. Right? And also, if your internet issue is sorted out and if you don't have VirtualBox, please install that. Go to virtualbox.org and install it. Okay? So I believe you would have done that. Right? Okay. So this is for this role. So while the entertainment program is going on, we can still work. Right? Yes. Yeah, what's it? Chalega. It'll work. If, No. You don't do anything here. I'm giving you the VM here. Guys, please understand, you don't need to create a VM. A complete working VM with all the setup is there in the pen drive. Okay? So all you need is VirtualBox installed. That's it. And I will actually guide you through the process of adding it into your VirtualBox list.
Guys, listen to Silva sir carefully, please.
Okay.
Yeah.
So again, let me reiterate. So you have a zip file inside of that pen drive. Copy it onto your machine. Pass it to the next person. Okay. Because it will take some time, close to about 5 to 7 minutes, because it's more than 5 gigs in size, right? That zip file. And the unzipping will also take about 5 to 7 minutes. Okay. Once that is done, keep it ready, and I will show you how to bring that virtual machine up. Okay. How many of you don't have VirtualBox installed? So please go to virtualbox.org and do the install. Okay? Guys, I think many of you are having internet issue, right? So at least can you connect with your mobile hotspot and download the VirtualBox and install it? No signal. Yeah, I've been having the same issue, right? So even a 1 lakh rupees, phone is of no use here. So literally I'm incommunicado right now. Or you can do one thing. You can actually Google it out. Give your this thing, how to enter BIOS, and then give your laptop's model number, HP, NV, 360, like that. When you give that, you'll get that info. But most of the times you see that in the moment you turn on your laptop. Press F11 or F12 or F2, something like that for entering setup. Go there, select the virtualization, and you need to enable it, otherwise it will not work. Okay? BIOS settings. BIOS settings, okay? So do one thing, for now, don't do anything, just copy it. If VirtualBox installation, okay, just do that. After that, if you try to run the VM, if it fails, it will report to you that virtualization is not enabled. So then you can do it. Because most of the times, if it's a new laptop, mine is a very grand old laptop, okay? That's a 10-year-old laptop. So in most cases, the virtualization probably would be enabled, okay? So how many of you are copied? Yeah, still the number is small, right? Okay. Oh, meanwhile, let's do one thing. Let's have a small Q&A. Who said no? You might as well walk out. You are here to get information, right? So the only option you had to that question was yes. So, anybody related to blockchain, programming, whatever? All good?
Guys, thank you for your patience. And yeah, I think we should thank each other. That was quite nice break in between. Let's welcome our speaker, Mr. Tejas, once again. Come on, guys, huge round of applause. He has been doing this for you, even with respect to the issues he has, sorted it out for you. So he will improvise. We'll do our best to cover all the things that are on the plate. All right, Tejas, over to you then.
Hello. Hello. Hello, I'm really sorry for the delay. So, yeah. So I'm not going to do a slideshow because there are code snippets within this presentation that I'll be using for running the palette. Cool? All right. So coming to the first thing, since this session is called Substrate Palette Enhancements, there are 2 points that you see on the board, right? So mainly for enhancements, as you can see, it increases product capabilities and allows performance scalability. So can anybody of you all tell me what do these 2 points mean? What do you mean by scalability of an application? Any hands? Scalability. None? All right, so basically scalability means when your application grows or serves a wider audience, right? When you, let's say when you're building an application, you target or you do an alpha testing, right? You do beta testing. But when it goes into production and serves a wider audience, your application has to be in a way where it can be scaled to that or to cater to that particular audience, right? So that is what scalability means. And the first point, increasing product capabilities. So enhancing means increasing or adding additional functionalities to your application. So that is what enhancement means. So that is what we are going to do today. Adding some functionalities to the substrate palette. I'll take you through the substrate palette again if you want. I'll do that anyways, no issues. And then we'll create two functions and add some helper functions which support those extrinsics as you learned in the previous PPT. And by the way, everybody has really good voices, so I was enjoying that. All right. All right, so building on the basics. So you kind of know the basics. You learned about macros, you learned about, so they are the building blocks of a palette, right? So we'll build on top of that. We'll add some functionalities. And this is a tutorial that Substrate provided, or still provides, I believe. And we'll be taking some functionalities from that kitties palette, going through the logic and brainstorming over that. Cool? All right, session 1. I'm sorry to eat up so much time. I think we'll have to fast track a bit. So, all right. Hello. Hello, hello. All right, so as you can see, we are on the branch called base template. I'll be creating another branch over base template and checking out. How many of you use Git on a regular basis? Version control? Guys, you have to learn version control because that is very important, since you'll be collaborating with other engineers once you get a job, and it becomes really a vital piece in development, that is. So I suggest you learn version control. All right. Yeah. So as you can see, in the previous session, they mentioned that the most important folders in a substrate template or basic node template are your node, palettes, and the runtime, right? So what we are going to do, we are going to make a palette, add functionalities to it, and then add it to the runtime and run the node. So I'll copy. All right. Okay, so as you can see, this is the lib.rs of your palette. Okay, and how many of you all remember the macros that were mentioned in the previous presentation that we need for building a palette? Okay, so I think that would be a no. Okay, so the basic or the most important macro that you need for building a palette is palette, as you can see here, and palette config. So every palette has these macros for the runtime to understand that yes, these libraries that you are integrating are actually palettes, and they serve as the logic for your blockchain. So whatever logic you have in your blockchain will be written into palettes. After you have your logic in the palettes, they'll be attached to the runtime. So that's how your node or your blockchain is developed. Right, now comes the PPT part. क्या हुआ? हेड माइक है? चलेगा। ऐसे हाँ? ऐसे? ऐसे? आ जाएगा? अच्छा भाई जैसे हेलो 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 It's working. Hello. No. Yeah, it's audible. You can hear me? Yeah. Can you all hear me? Okay, okay, I understood now. Yes, right? I am on mute. Okay. Uncomfortable, but ठीक है. All right. बट ठीक है कोई इशू नहीं है मैं माइक लेके चला जाऊँगा थोड़ा अनकंफर्टेबल ठीक है कोई बात नहीं कोई 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 नहीं इशू कोई नहीं इशू माइक इज वर्किंग all right, so I copied and pasted a code from the presentation, and as you can see, we are going to use these imports for creating our extrinsics. Okay, and can you all tell me what are extrinsics in a palette? Anybody? Any random guess, any weird guess भी चलेगा कोई issue नहीं. What are extrinsics in a palette? Okay. Okay, so extrinsics are functions. Simple. Nothing more to that. So extrinsics are purely functions in which you write your logic, and that function you access from the UI. Cool? Is it okay if I say cool? कोई weird नहीं लग रहा ना? All right. Okay. All right. So, okay, so I'll tell you about the imports. So these are basic imports that we use for our palette, like frame system and frame support. As you can see, it was previously also there. Now we are using like randomness, currency, tokens, and existence requirements. So I'll explain to you when I come to the functions that we create. And we are also using an algorithm called Blake 2128. So it's a hashing algorithm. What does 128 mean? It means it hashes using a 128-bit encryption. Okay, so it has a 128-bit क्या कहते हैं, an output, and with that you hash your data, which becomes secure in turn. Type info, it's a translation layer, as you already know. It basically gives the information of types when you're using Rust precisely. Deserialize, serialize, if you all have idea, serialization is basically converting to string, and then deserializing is converting back to the object. Am I right? Is that how deserialize and serialize works? Anybody? कोई भी चलेगा.
Guys, make sure that you interact. That's how he will know that you are learning, and you guys will also know much better.
Yeah, and you all can stop me at any point. कोई issue नहीं, ऐसा नहीं कि सुनते ही जाना है. You all can stop me wherever you feel uncomfortable, या कोई ऐसा code piece दिख रहा है जो नहीं समझ में आ रहा है. That is also fine. Cool. All right. So I have copy pasted palette imports. Now I'll go to the configuration. So there are two things in configuration. This is all part of making a new palette. Okay. So let me be very clear with that. So when you remember I copy pasted the template module again, right? So you can have multiple palettes in that palettes folder with any name. You can give your palettes any name you want, just not the same name. Like two palettes cannot have the same name. Okay, so configuration, you will be copy pasting or not copy pasting, you will be integrating in two places. One is lib.rs of your own palette, and one is lib.rs of your runtime. So you have only one lib.rs in your runtime, but your palettes, as it grows, will have multiple lib.rs consecutively. Cool. I'll copy and something. You see this config? Can you all see? Theme ठीक है ना? All right. So I'm going to replace this config with the thing that I. All right. I'll just indent it a bit. Okay. So this is the config that we want for our palette, and as you can see, there are types in your configs, right? So what makes this config a config for the palette? It is this macro that is defined on top of the config, right? So it is just a trait. If you remove this thing, it's just a trait. It's not a config anymore. Okay, and your config can have any name, but provided that you have the palette config macro on top of it. What does this mean, frame system config? It's just like inheritance. So one class will inherit properties or methods of another class. That's what it does. So config knows that it can implement or it can use the config of the frame system library or palette. All right. So what do these type? You see types a lot in configs, right? अभी ये type का क्या मतलब है? These types are basically type aliases. Nothing much. So it's just saying that I want my type name to be event, currency, max kitty owned, kitty randomness. You can have any name for your type, but on the right hand side, it's your type is basically identifying itself that I want these types to, or I want to be built on top of these types. I want to alias these types. Is it clear? Who all have worked with type aliasing? So do you all understand the concept of aliasing, type aliases? So okay. For example, let's say have you all worked with integers or strings? All right. So okay. So yeah. So you with the type keyword here, you can, let's say, create a type called Tejas. Obviously, you will use your own name. Let's say if I create a type Tejas colon string, so Tejas will also be string. That is what aliasing means. So it's exactly that. Currency, matlab I'm assigning currency to it. Currency is also a type like string, right? It's that way. You can see one more macro that is palette constant. So you want this type to be of a constant number, which will not change in the future or at any point in your blockchain's runtime. Have anybody worked with generics before? You have a question?
We have a question, yeah.
Sure.
So, if you don't mind, would you please start it again? Like, it's kind of a little overwhelming to us, so.
Sorry, I couldn't.
Like, if you don't mind, can you please start it again? It is kind of overwhelming to us.
Yeah. So about that. So what we'll do is you can give a overview in verbally, and as far as starting again is concerned, you can obviously later on check out the YouTube video where it'll be live. So Tejas, if you want to give the overview again, maybe.
Sure. Hello. Okay, so all right. So how many of you are understanding what I'm saying? Be honest. Be honest, really. No, it's fine because the first time that I also saw the code, I was like, okay, kya ho raha hai? I did not understand. Okay, but this workshop is basically to give you an idea of what substrate is and what to identify when you see this kind of code, right? Obviously, when I am talking like this, kisi ka palle nahi padega. Many of you all have difficulty in understanding what I'm saying, but this is just a how do I put it? A walkthrough of the substrate palette, right? The possibility of building such a palette is for you to know about blockchain also. That is firstly, and secondly, how to build one, right? So you wanted an overview, right? Overview of what? Of the workshop. From the code perspective, that is. All right. Okay, I'll start from the beginning. Yeah. Hello. Okay. So firstly, I'll go to Google. I'll go the simple route, okay?
Guys, you can follow this.
First, go to Google, guys. I hope your Google is working. On Google, if you have Google on your laptops right now, type substrate node template. All right. You all found substrate node template? On GitHub, yes. Clone that repo. Go inside GitHub, go click on that link. You all have worked with GitHub, right? And what about this side? इधर से इतना आवाज नहीं आया इसलिए. All right. All right. Did you all clone? A big yes. Big one. समझ में नहीं आया. You all have cloned, right? Can you open that in an editor? Can you open that folder called substrate node template in an editor? Any editor, Sublime Code, VS Code, Vim. Sorry?
Sir, how to clone?
Okay.
We've never worked with GitHub.
Okay, so there is a green button when you go on GitHub called code. When you click on code, there is a copy button, right? So click on that copy button and then go to your terminal wherever you want to clone this repo, okay? Clone is basically copy pasting but from web to your local. Okay, that is what clone means. So the command is git clone the URL that you copied from that repo. Backbenchers, have you all cloned? How many of you all have opened the substrate node template on an editor or in an editor? You have? Can you tell me what do you see in that template? Right. So Okay, we'll wait for like 1-2 minutes for everybody. Just give a big yes when everybody has cloned, okay? And the ones who have, you can go through that palette template or the palettes folder, which has the template folder, okay? And you can go through the lib.rs. That is what I'm explaining here. Just try to identify the pieces. I think it's just 100 lines of code. I think the first thing has to be identification.
Tejas, you want to walk around and take a look?
Yeah, sure.
How many have cloned? Hands up. All of you who have cloned. Okay.
Do you have Git installed? Hello? 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 So it is 10%, okay? So when we have all the resources, we have 100%, you see the folder in admin. Okay? Git is not installed. Oh yeah, how many of y'all have Git installed firstly? Okay, so Git clone kaise chalega? So you'll have to install Git clone also. Let's be aware of Git chalega first, because that is very, very important. Version control is very important. Okay. Yes, you need to install Rust also. But what my intention for you is to just go through the code. We'll do this in Substrate Playground, which already has Rust and everything. So it is a cloud-based platform. Okay. All right, guys. Let's get so. हेलो ऑल राइट, तो यहाँ पे बहुत लोगों को गिट नहीं पता है ना, दैट्स ओके, बट shall we do a git installation here now? चलेगा? Hands up. Cool. Let's do a git installation. Let's start from the very beginning, version control that is. Then you can do git clone. Please do git clone of this repo called substrate node template, all right? And then go through the code. And also learn Git very, very well. It will really help you when you are, handling a project, when you're collaborating with other engineers. Because when I was doing engineering, nobody told me about Git, and I really, really struggled with that. Okay, and I had to like go through stuff, and people were Git cloning and Git pushing all the time. I was like, "Kya chal raha hai?" I had no idea. So this is very important. Do learn this. So let's do a Git. Let's do Git installation today, and the main thing for you today is to clone the repo. All right? Cool. And those who have cloned it, please go through the substrate node template and the folders that you have, like node, palettes, and the runtime. So in palettes, you have your logic. Go through the logic, go through the resources that are there in palettes, and just try to understand or identify the macros that were shown to you in the previous presentation. Utna hi hai. Let's take one step at a time. Let's not jump into 100 things together because no one will understand. So my main point here is to make you understand at least something so that you get interested in this wonderful technology that is Substrate. All right? All right? Nice. I want a big yes when y'all have cloned, okay? That is like a very big achievement, and y'all can give me a high five. ठीक है? Super, अच्छा इन लोगों ने कर दिया. Cool. Can you all do that in 10 minutes? So I'll tell you more about this. So version control is basically, there are some commands that you need to know, like by heart. Small commands, कोई ज़्यादा बड़ा नहीं है. When you are in your folder, that is in your project folder, you just have to do git init. That is the first thing that you need to do. Initialize git in your folder. Okay, anything needs initialization, right? So after you initialize, you make the changes to your code, Git tracks it locally, and you just, after that, you add the files to staging. ये सब नहीं समझ में आएगा, just understand what I'm trying to say, or just, क्या कहते हैं, flow के साथ जाओ. So first you do git init, make changes, do a git add, stage the files for क्या कहते हैं, for committing. So staging is like a temporary commitment, and once you do a temporary commitment, you permanently commit it. So the command for that is git commit, and with that commit you add a message. Okay, so 3 commands till now: git init, git add, and git commit. You all can look this up on Google. And after you commit, you do a git push. Git push matlab it will store all your code in cloud, that is GitHub. 4 commands. So how many of y'all liked Polkadot compared to Ethereum or Bitcoin? How many of y'all understand what Polkadot is compared to Ethereum or Bitcoin? थोड़ा. Fine. तो Polkadot का सबसे main functionality, just you have to understand, is that Polkadot has within itself multiple chains. It is not like Ethereum where you write smart contracts, right? So you write smart contracts and add functionalities to the Ethereum main chain. But in Polkadot, you have a chain within a main chain. So if you can run substrate, and let's say if you add a good logic to your substrate palette and add it to runtime, maybe it gets selected in the Polkadot ecosystem, and your chain becomes a blockchain. So that is the potential of learning substrate. You can build your substrate from scratch. So there are 3 ways you can build your substrate from scratch, like your palettes, and there is a node template. What we are doing here, we are doing with palettes, and that is called frame. Okay. क्लोन हुआ, डाउनलोड हुआ सबका? Now do a git clone. 2 minutes. सबका हो गया ना? 2 minutes. And any issues, please raise your hands. कोई problem नहीं है. I'll summarize. But you all can share also if cloned guys. Okay. Can you open your code in an editor? Which editor do you all use? Okay. Anybody uses Vim? Okay, fine. Vim is actually hard in itself, so I understand. Are you all able to see the code? Can you all tell me what you all see? No, can you all see the node palettes and the runtime folders? Can you all go to the palette folder? Can you all go to the template folder? Tell me if you all can go to the template folder. If you all can go to the template folder, open lib.rs. Lib means library. And just tell me that you all identify these 5 macros. One is palette config, palette events, palette errors, and palette storage. मिल गया? और किसको नहीं मिला? हाथ ऊपर. You all got it?
Yeah, guy. Internet bandwidth and mic. Hello.
For the command to get the clone from like terminal from the Visual Studios, get
clone, like you did git version, right?
Yeah.
So it's git space clone. Okay. Hyphen hyphen. Sorry, not hyphen hyphen. The URL that you copy of the GitHub repo. Where will you find that GitHub repo link?
in the GitHub that we get it right. We opened it right in the template. Yeah, yeah. I copied it out.
All right, guys. Did you all learn anything new today? I'm happy. It's okay. It's not substrate, but we'll get there eventually. Yeah, gradually. But these are the important things that you have to take into consideration. Just also do do a course in Rust maybe. Try to understand Rust also. That is also very important because I do. Hello. 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 Yeah, where was I? Rust. Yeah. So Rust is also very important because Substrate is built on top of Rust. And once you understand the basics of Rust till generics, there are 10 chapters in the Rust programming language. It's called the book. If you type the book for Rust in Google, it'll pop up as the first link. Just click on it. If you learn 10 chapters of it, it's up to generics. You'll have a good understanding, pretty good understanding of what Substrate is trying to do and how Substrate has implemented all the code functionalities that you see inside the lib.rs or any other file in the Substrate node template folder. All right, folks. I think we can stop here. So what we can do is that I think I can shoot a video explaining the Substrate node template. Will that be okay? And share it with you all. Okay. But you all were able to go into the node template folder, right? Cool. And so sorry for the delay. It wasn't intended. But thank you for being such a sport. I heard a lot of nice voices, just like I mentioned previously. So thank you for that really entertaining session. And thank you all for coming. Thank you so much.
Okay, guys, raise your hands if you learned something in last 1.5 hours. That's huge. I think we need to understand the amount of work Tejas has put in the last 2 hours. That requires a lot of patience, and at the same time, we also have to appreciate the amount of patience you guys have put in the last 2 hours. All right? So give it up for yourself, give it up for Tejas for being such a sport, like he said for you, but I would say the same for him, for being with us, and I'm sure he'll be here for more time right now. Yeah, so you can reach out to him, but make sure there's no commotion, one by one maybe, and ask your questions. And if he has time, maybe he will scan through and speak to you as well while we move on. So wait for my next announcement. In next 30 seconds to 1 minute, I'll be back with you. please continue working on what Tejas has just suggested. I know about the internet. I know about the internet. Trust me, I know about the internet. But our team is working on it. All our teams are dedicated to into sorting that out. How many of you are facing? Okay, I don't think. How many of you are using the internet? Okay, that's a lot. Wow, you are using the internet. Amazing, good. So that basically pretty much shows that more than half of us have access to the internet. So regarding that, you do not want to connect to the mobile with the Wi-Fi. Do not do that, please. That will be too much stretch for the internet bandwidth and for the access that you have. So just use on your laptop, and people who have issues with the internet, we will try to sort it out. Okay? I'll be back in a minute with the next announcement. Just give me a moment. Guys, who has the pen drive over here? The pen drive passed by Salva sir? No, they have it. No. Yeah, are you done with it? No, is it taking time? Do you have internet access? Yeah, so if you have internet access, then use it. If you don't have internet access, don't wait for the internet, just pass it on, so we'll be able to cover maximum people, okay? So generally, how much time is it taking to transfer? Yeah, so we'll sort the pen drive out. Similarly for other people as well. Where is the pen drive over here? In this row? This row, pen drive? Nice. Where's the pen drive over there? Can we make it quick for everybody, pass it down. It's going from down to up, right? Okay. Where's the pen drive on the last? Okay, great. Let's speed it up. If you have the internet, transfer it. If you don't have the internet, give it to the next person who has the internet. Okay, let's not wait for the internet to do the transfer, because that will take a lot of time. We'll cover up with students who have access.
What are the files that are present in that pen drive? Can anyone answer? The pen drive.
I thought you were asking. My bad. Okay. I'm not sure. I think Selva sir has passed it. How many of you all want to learn more? Raise your hands. Like you got a trigger, right? That there's something that is happening. That's all. Nobody else wants to learn. Yeah, nobody. Okay, maybe some of them are busy. I understand for the people who are busy on their computers. Guys, take a second and raise your hand if you want to learn more today. So everyone, no? No? All right, good enough. That's a positive, that's an encouragement for me. And of course, we have Selva sir over there and Tejas working. If you have any questions, you can reach out to him. You can go and ask him the question, that will be okay.
Hi. I would need your attention, please, everybody. Students? Thank you. Okay. I've just been informed that there is a certain situation with respect to transportation. I would like to know, by a raise of hands, how many of you are coming from college transportation via buses? Guys, I would need your hands to be to the top, please. Okay. So nobody in that row, nobody in this row. This one probably 10 people here and 20 people here, correct? So do you have any timings on the buses? What time? What time you guys are supposed to head back from here? 5:30. It needs to leave from here, is it? So do you go back to the college and then you go home? So it drops you back home individually. So do you have the supervisor here from the college with you? So do you have any senior person from college, from the teacher's side? Or you just go sit in the buses and go from there? So can we request for 15 minutes? Because so if you are looking for an extension of about 30 minutes for 6 p.m., whom can we talk to? We can talk to your college, we can take permission for 30 minutes, guys. So do you have the transportation head's number or some manager with transportation? No, but we won't be able to. Sorry? For you guys, it's manageable? For you guys? Okay, anybody who might have an issue, can you raise your hands, please? Okay. Yeah, so guys, we can get in touch with the college or we can get in touch with the transport team, we can take permissions. You don't need to worry on this. But you'll have to get me some contact numbers with your colleges so that we can do it right away so that there's no stress on you guys. Because see, we are putting in effort, we have started with the program. We don't want students to miss halfway through. You've just started with the basics. The best part of you actually learning to develop is going to be coming in the next 3 days. So we don't want people to learn the basics and then when you actually start to develop, then you guys miss out because of the pressure of the 3 days, right? So which college are you guys from? All of you are from Anurag, right? So that would just be one bus is what I'm guessing. Correct? So you guys in the center row, it's fine for you guys with respect to your buses. They'll stretch, right? Okay. So the first and second row from the left, please. Are you guys on the same page? Would be okay for you to travel back if it's a little stretched? Can I hear a yes, please? Thank you very much.
Thank you, sir, for sorting that out. So if anybody else has transportation issue, then just reach out to Ali sir over there. He will sort it out for you. Okay, so yeah, keep working. We'll be back.
All right, students, while that's happening, what I recommend and what I suggest is we create a step-by-step guide, because we have so much content, so much overwhelming, not understanding Polkadot process, GitHub, Git process, your setting up of Rust, the environment. I suggest we create a step-by-step guide of how we follow the steps. There is a consistent issue with the network here. People are not able to download, people are not able to set up, there is disconnection happening on the network. What I suggest is we just go over the steps on the screen now. I would want everyone, whenever you reach home safely, follow that process step by step, starting from the environment setup, the virtual box, the tools required, the IDE required, and then come back in the morning with the setup, the runtime, the files, the lib.rs files, all that other stuff that was explained. I know it's learning, but it has to be structured and a little bit more organized. So I'm assuming people can hear me, but I want everyone to follow this process. Come back tomorrow, make sure that we know what the problems are, and everybody here is intelligent enough to know the points that we are lacking. Each system. Some people do not have a system. Some people have a system, but it's not working. Some people have a system which is slow. Some people have a system which is 4 GB RAM. Some people have a system which is 8 GB RAM. Some people have Ubuntu. Some people have Windows and things which are working and not working. So we'll take feedback from Selva sir. We'll take feedback from everyone here. And Selva sir will help us with all the step-by-step guide. And any issue we have, we can raise and escalate and try to solve and save time. Okay, everyone can hear me, correct? 2 announcements. I got it. Okay, so one is people are responsible for their own stuff. Your laptops, your phone, your bags. We do not want anybody coming back and saying my phone is missing, my laptop is missing, there are no cameras here. Or even if there are cameras, it's very difficult to get access to their own stuff. Please make sure you're responsible for your own stuff. That's one. Second is there has been some instances in the past where people left from here and there were some unforeseen issues, some accidents or some travel, being late. We have been instructed from the Spoks that people who are traveling and going late, they just put a message in whatever format, whether it's WhatsApp or what's the preferred way of communication, WhatsApp message? Reporting to your Spock that you have reached home successfully. It's we do not take liability of any student after they leave the premises, because again, it's the responsibility. We want to make sure that people are safe, and college Spocks are equally responsible for your own safety. So we want to be sure that every student, once you reach home, just ping a message to the Spock. Every college, every associate here, they should know that, okay, my day is over, my attendance is recorded, and that you're safe. Okay? Sir, you ready? How? एक बार गया तो फिर वापस नहीं आते. All right, here, sorry, how many people are able to set up the environment with the virtual box and the installation? About 50%, 60%. And the remaining, I would want to know what the major issue is. Is it the network connection or is it, okay, network connection. Sir. Okay, how many of you don't have VirtualBox right now? How many of you? I think the number has considerably reduced. Okay. So at least from the pen drive, copy the entire virtual machine, go home, or at least you can go inside the lobby where you have mobile signal, use your hotspot, and get the installation done. It's hardly a matter of 10-15 minutes, okay? That's one thing, yeah? Installer, yeah, we could do that. So if people have the USB and the installer, you don't need the network for the setup, correct? Yeah, but we have not put that up on the... We have 6 USBs, 7 USBs. I didn't put that. Okay, so we can... So we have a solution where we have about 6 pen drives that we can use, and we can, whoever has a problem, we can just put the installable file on the USB and circulate it among, so at least about 20 people or so who do not have VirtualBox can set up in a matter of, let's say, a few minutes. I want to make sure that at least the time we have today, we set up everything and we start fresh tomorrow, so we don't waste time again on the setup and the network tomorrow morning. I want to make sure that everybody's machine has this setup complete, and then anybody do not have it, please take it in the USB, and then we can do the installation. That's quick and faster. All right, so quickly we'll have a short session with Selva sir, who will explain the setup again one more time, step-by-step guide. We want to make sure that we go past this setup problem, network problem, and the environment setup problem. So, sir, is this? Okay, guys, so let me give you some of the installation instructions, okay, for VirtualBox. Now, please look at the screen. Guys, please look at the screen, okay? So you need to go to virtualbox.org.
Guys, so stop everything that you're doing and see what Selva sir is showing, because that is important. It'll take just a few minutes. Everybody stop what you're doing, see it. Once you are clear what he's saying, it'll be easier for you to understand.
Okay, so let me show you what you need to do. If you're coming first time and installing, probably you're going to download and install VirtualBox 7.0. And many of you might have VirtualBox already installed. That would be probably 6.1.40. That was the last release on VirtualBox 6, okay, version 6. So apart from that, generally what we do is we come to this site, okay, and we simply click on this download and we install it, done. But in addition, what you should do, okay, let me show you that. So click on this, download it, and install it. So once the installer is done, there is one more VirtualBox installation required, which goes by the name of VirtualBox Extension Pack. Okay? So I guess most of you would not have done that, right? Okay. So what you need to do is go to the downloads link here. Okay? And you see here, VirtualBox Oracle VM VirtualBox extension pack. Okay? It is for all supported platforms, so you don't need to worry about it. Okay? There's one simple download. Once you have downloaded it, okay? So if you're using Google Chrome, so it just appears here. So just run the file. What will happen is that file will automatically get opened up in VirtualBox, and just click yes to install it. Finished. Okay? It's as simple as that. Download the extension pack and just run it. That file will automatically open in VirtualBox, and the extension pack will get installed. Okay? Extension pack gives additional capabilities to your virtual machines. Like for instance, you can do copy and paste across VM and the host machine, VM to VM, all those things you can do. But without that, you cannot. Okay? That's one thing. And the virtual machine that I have prepared for you on the pen drive, it is actually using extension pack, so you will need it. Okay? So when you try to import the machine and try to run it, you're going to get extension pack related issues as well. Okay, second thing. I also noticed some of you are actually copying the zip file onto desktop and then unzipping it there itself. How many of you are doing like that? Because I noticed that will also, can you raise your hands please? Anyone who has copied it on the desktop? Okay. So you should not be doing that, first of all, okay? So basically, desktop is the place to put all your trash, right? My wife's laptop is also like that. She opens it, and it's full of icons, and I hate it. Anyway, so it's like putting trash in your living room. Imagine when somebody enters the house, okay? So you should not put all this on the desktop. It's not meant for that, actually, even though almost 99% of the people, including developers, they do the same thing. Anyway, so let's forget about that. So if you put it on the desktop, the VirtualBox will have issues in accessing it, okay? So what you should do is, even if you have copied the zip file on the desktop also, when you extract it, the extracted folder should not be on desktop. Instead, put it on your C or D drive, okay? And then use that. Got it? Otherwise, you'll get accessibility issues. Okay? Now, guys, please listen. Without these instructions, if you fail to install, nothing is going to work. Right? So please be attentive. Okay? Now, apart from this, sometimes you will also get Microsoft Visual C++, okay, redistributable error. Right? So in that case, what you need to do is just Google for say here, so you already get this thing, Microsoft Visual C++ redistributable. And here are the redistributable downloads, okay, from Microsoft. So just go to that site. And on this page, when you come down, most of you would have an Intel or AMD processor, so you can just click on this x64. So it will download the installer, okay? It's simply an exe file, small exe file, and then you run that. When you run that, now why do you need this? Because VirtualBox inherently uses many of the Visual C++ libraries. So you need to have that installed. So if it doesn't find, okay, you're going to have this error. So it's pretty simple. The solution is very simple. Come to this page, click on the x64 link, download it, install it. Once the installer is done, so what this installer will do is basically download all the required packages and then install it on your system. Once this is done, you can install VirtualBox. Okay? So whenever you see Microsoft Visual C++ redistributable is to be installed, so you need to do this. Okay? Right. And in fact, this is also needed for your Polkadot environment setup and stuff also. If you are working on Windows, which is not recommended, we'll be doing it in Linux environment. Okay? Because primarily it was, the whole source code was actually developed for Linux only. That is the reason we are using Linux. However, for Rust, I'm sorry, you don't need Linux. You can work on it with Windows as well. Okay? You don't need a virtual machine or anything of that sort. You can do it on Windows as well. Now, coming to Rust, okay? So before that, so I have a small presentation here for the Polkadot dev environment setup, okay? So you can actually, take pics of this and use it for your purpose. So this is Rust installation on Linux. How do you do that? Okay. So if you are using a Debian-based distro, like Arch Linux, Ubuntu, Debian, all these are Debian-based distros. You need to use this command. Okay. If it is Arch-based distro and Red Hat or Fedora, CentOS, the third one. Fourth one is OpenSUSE. I don't think anyone will be using OpenSUSE here, right? It's a fantastic distribution, actually. Okay. So this will be shared on the Discord as well. You can utilize that. Okay. Then, apart from that, you need for installing this. So that is the prerequisite. If you see there, these are the required packages to start with. Okay. Once those packages are available, then you install Rust. Now, to install Rust and its tool chain, what you do is there is a package called as Rust Up. Okay. That actually installs the complete tool chain. So this is the command for Linux. Simply curl and then download it and then run bash over it. It's a shell script. It runs and then does all the installation for you. Okay. And in case if you have any question at any point in time, please interrupt me. Okay. And for macOS, these are the prerequisites. One is, OS should be 10.1, macOS 10.1 Mountain Lion or later. Okay, 8 GB at least you need. And this is in general, as far as the processor speed, memory, and storage is concerned, it's common to all platforms. Okay. 10 gigs of space. Yeah, and it also says broadband internet connection. Right? You need high-speed connection because a lot of downloads happen. Okay? There is support for Apple M1 processor also. So for that, you have to run the software update command in macOS. Okay? And on a Mac which runs on Apple M1. Okay? So once that is done, macOS we use Homebrew. Homebrew is nothing but it's a package manager which does all the installations. Okay? Just like in Linux you have Debian-based distributions, you have apt. So that's a package manager which is used to download and install software. In Red Hat Linux you'll find a yum installer. Okay, so likewise. So macOS there is a package installer called as Homebrew. So first you need to install Homebrew. So there is this command over there. And then to install the required packages, first you need to update, brew update, and you need OpenSSL package for OpenSSL connectivity. And then the same curl command that I showed you for the Linux environment. Okay. Now I guess, how many of you are using Linux? Just please raise your hands. One. There was one macOS also, right? So that's also Unix, like 2, 3. Okay, fine. Right. Okay, so once this is done, on Linux or Mac, you have to run this command. You need to source it so that the Rust compiler and all the tools, they are available on the path, then only you will be able to start working on it, okay? Windows. I guess rest of the entire crowd is Windows-based laptops only, right? Including mine. Okay. So, but basically I use Windows only to boot my laptop, and the entire day, rest of the day, I use Linux only most of the times, okay? I hardly ever use Windows other than maybe prepare some presentations and stuff like that. Other than that, I always use, so I have multiple VMs in my machine. So depending upon my application. Okay, so for Windows, one is you need to have Windows 10 at least, okay? Or you can use Windows 10 version 2004 or less. Later, Windows 11 will also work. And Windows Server, it runs on Windows Server as well. 2019 minimum, okay? Right. It also, the last part also says good internet connection, because a lot of downloads happen during installation process, okay? It's not like you download the installer and run it and then you don't need any internet connection. So all these are offline, online installers, okay? So you go to rustlang.org/tool/install. This is the, so what you can do is, there is this, as I mentioned, the Rust Up tool is there, which does the entire toolchain management installation, okay? You can go to this link. You can try this out. Is internet working? If it is working, okay? So rustlang.org is the website, okay? You can go there. You'll find the install instructions for all the platforms. It will automatically, this page automatically detects your operating system, and based on that, it gives you the download links, okay? Let me just show you that. Oh, I think, yeah, here it is, good. Okay, so this is the install page. If you go here, you can see it already detects, so it says it looks like you're running Windows and blah, 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 blah. And see here, you may need to install Visual Studio C++ build tools. It is the same thing that you needed for VirtualBox also on Windows, right? Okay. So if you have done it for VirtualBox, Rust installation will progress without any issue. If not, Rust installer itself downloads it for you. That's the beauty of this. So you don't have to separately go to the Microsoft website and then download it, okay? The Rust installer does it for you. So, so here you can download 32-bit or 64-bit, whichever version of operating system platform you're using, okay? It's just a simple exe, just run it and follow through. That's it, pretty simple. And also, if you want, what you can do is, instead of using a virtual machine, okay, instead of using a virtual machine, there is another option available, which now Windows supports. It's called as Windows Subsystem for Linux. Have you heard of this? Have you used it? Have you used WSL? Windows Subsystem for Linux? I can't hear. Okay, so it's basically Linux running under Windows itself, so that you don't need to install any separate software. And Ubuntu is available for download and install. You can go to the Microsoft App Store and you can download it. It's freely available. Okay, and you will have, but again, no GUI. No GUI. And I know that most of you are actually, you know, I'm basically a command prompt guy. I do almost everything in command prompt, okay? But you are used to GUI, so that's the reason I actually put the VM that I have given you has a GUI, right? Whereas WSL, through that, if you do it, you'll get a Ubuntu distribution without any GUI, all command prompt only, okay? So well, if you get used to it, so here is the command that's given. I think probably you might not be able to read this, but this instruction is there in the PowerPoint presentation. I'll just show you that. So again, once you have the WSL2 installed, same curl command, okay, which you used for Mac OS as well as for Linux. Okay, this installs the Rust up toolchain. Linux Debian GUI. Okay. Right. So installing Git. Right. That's the version control system that we use, and the most popular one nowadays. Okay. So first you need to update your package repository using sudo apt-get update. That's the command. So whatever you see in the in bold there are the commands that you have to issue, and in this order only. Okay. So first you update your package repositories. Once you're done with this, simply use sudo apt-get install git-all. It will install all the complete toolchain for you. That's it. And this is, if your internet speed is good, it hardly takes a minute. Hardly a minute. Okay. And after that, you can check. Just give the command git version. You should see the git version of git. Otherwise, it will say, the git command was not found or something like that. Now, in case of Debian and Ubuntu, you have to use the apt-get in order to install that. Okay. For Fedora, we use DNF. That's the package manager. So when the distro changes, the package manager also changes. Like for instance, Arch Linux, they use Pacman. So these are the package manager tools which are different for different distributions. Okay. So use sudo dnf install git-all, and then use git version to test whether it was installed successfully or not. Okay. You can also do git installation from an installer for macOS. This installer is available on SourceForge website. Okay. You can use this. And otherwise, you can also use the homebrew command. So using homebrew, just give brew install git. That's it, finished, done. Just one command and you have it there. If you want to install Git for Windows, there is a website, gitforwindows.org. Go there, download the installer, run it, done. You will get Git Bash, okay? And you will also get a Git GUI also, which you can use, right? Building blockchain using Polkadot, this we are going to do tomorrow now, probably right now. So you saw those installation instructions, so it's very easy, right? Now, these instructions I will show you in the next session. However, this has already been done for you in the VM, so you don't need to do it at all, okay? But still, guys, listen up. If you still face any issue, put your questions in Discord, okay? And we will reply to that. Okay, any question, please?
Okay, so few things very quickly. I think we would want to have some homework today for everyone. Think of it as a college assignment. This document will be on Discord. Now, people who have questions about it's working on my friend's system, it's not working on my system, we want people to collaborate with each other. I'm assuming that from students who are from the same college, one installation is working. Do we have people here who say, all of my college students, nobody has the setup done? Which means that there is at least one student in the group for which this setup is working. Because tomorrow morning, I want to start the development. I don't want to spend time on network issue, radius issue, kit issue, version issue, laptop not charging, all kinds of stuff. So an assignment for everyone, Please make sure all of this is working. If your system is not working, there is no shame in asking your friend about the setup. One good thing I like about this is everybody has a laptop. I see most of the systems laptop. I see people who are interested in knowing about what is Rust, people who are interested in about what is Git, whatever. I don't want to go into processors and all, but good thing is that I see most of these people, students here, have their machines interested in learning. I see some people who are trying to do stuff, but very important, get this document step by step from Discord. I'm assuming everybody is on Discord here. Okay, an assignment for today, please make sure that we resolve all of this. There are some restrictions from the facility here in terms of the network, the usage, one ID, one access to the desktop, and then still we are facing so many, like 300 people accessing the same internet. We are getting slow bandwidth and other things. We want to make sure that the USBs are circulated, do the installation, complete the setup, complete the download of respective versions. I'm assuming, as sir said, 95% people are all Windows. So set up everything. If you have already set up, I would say go to YouTube from home. Don't watch House of Dragon and then just spend time on what is Rust. Learn about Rust, learn about Polkadot, what the ecosystem is, what people are doing, and what is the development process. What is, as our friend Tejas was explaining about, and so was explaining about RS file, what is an RS file, what is their extension, what are those functions available. I think all of this is all technical stuff which will give you an advantage for you to learn and speed up the development process. Very, very important. We don't spend time on Googling stuff, but very important that you understand this technical jargon of Rust, your parachains, your Polkadot, what is Polkadot, how are they doing Rust, why are they doing Rust, what is the language, what is substrate, what are palettes, what is the standard palette, what is the runtime, and a few other things. So very important. Tomorrow, we want to see 95% people or 100% people finish this problem of the setup and the environment setup. And if you have time, don't waste time. And focus on learning. Very important, YouTube, you cannot build and succeed everything on YouTube, but at least you will get the basics right about Rust language, the substrate framework. Another important announcement on the portal, the IBC media portal. We are seeing some restrictions on the network here. For example, it's working when I am connecting my hotspot. If I'm working when I'm connecting from this, we are working with the facility to resolve the firewall issue or the network limitation issue. Yesterday when I did the demo, it worked. Today, because so many people are trying to connect and fill the application, there is an issue on the network. We're trying to figure it out. It works from my home. We have got about 190 people who have registered on the platform. We want 100% participation. Finish the hackathon application, choose the track, fill the application. As all the incentives were mentioned yesterday, we want to make sure that if you have any questions on the track, if you have any questions on the ideas or your problem statement, please reach out to any one of us in terms of what you want to build, how you want to build, and take feedback. Very, very important.
Yeah.
Sir, you were saying something.
Okay, guys, can I have the projection, please? Right. So you can even go do this on your mobile. Go to, of course, all of you are having the same issue. There's no signal as well. Okay. Anyway, so go to YouTube. One of the best resources to learn Rust is a channel called Let's Get Rusty. Okay. So go to YouTube. This guy explains concepts very well. Okay. Even I have used it. So, and also he gives you all the updates that have happened in the Rust world, okay, including the latest version release that happened recently in Rust. So Let's Get Rusty. Remember that? That's the YouTube channel. Okay, and there are short, 10, 15 minutes videos on just about every important concept in there. including some of really advanced stuff like traits and metaprogramming and Rust and stuff and the likes, metaprogramming and macros, macro writing and all those things. Okay, so at least you can go to this channel and get introduced to Rust. From tomorrow onwards, we'll actually start working on Rust. By the way, how many of you are still left to copy the virtual machine? Oh, good number. Hey, where's the USB drive? Is it not getting passed on? Who is using the USB drive right now? No, we have supplied them 6 of them. So guys, please, those of you who are yet to wait for the virtual machine, please wait. At least ensure that virtual machine is copied onto your machine, okay, before you leave. We do not want to spend any more time on these setup issues.
Yeah. All right.
Yeah. Yes, sir. Please go ahead.
All right. Good evening, everyone. I hope you remember me from yesterday. I was a backbencher. I was the guy who was almost kicked out of the school for attendance, but I did fairly well. So how many people can remember what I asked yesterday? And I asked you, can you do it? I can do it. Anybody has any doubt in their mind that they can't do it, please raise your hand. That you cannot do it. Clearly, we have made progress. This is step number 1, believing that you can do it. All right, so, I'm going to take much less time than yesterday, I promise, because I know it's already late, and some of you want to get home. It's not easy to sit in your seat for a day, but you guys have been very kind and patient. But I want to talk about quickly skills. Skills that are required to be a successful Web3 developer. Can anybody take a guess? I'm going to give 5 chances to see if you guys can get at least a few right. Anybody? Guess. Come on. Guessing is easy. Pick a word. You have to go to the gym. You should know how to dance, how to sing. Take any guess. What skills are required to be a great Web3 developer? Sorry? Patience, hard work, explore. Guys, believing is the first step. Confidence. What else? Persistence. What else? I mean, these are things that would help you in anything you do in life, but what about being a Web3 developer? You're close, but not quite. Skills, guys, skills. Get up. Who said that? A round of applause. I think I mentioned it yesterday a few times. Good job. Googling is number 1. You can sit down. What is the second one? Who said YouTube? Please get up. Round of applause for YouTube. All right, so there are two more critical ones. And now you have to come down to my level and think. You so far have been thinking at Silver Sir's level. Who said Telegram? Get up. Round of applause, guys. You need to be a social media magnet. If you don't know social media, you will not interact with the global community in Web3. So we have covered Google, where you search what you need to. You covered YouTube, which is your knowledge bank. Sir just gave you an example. Let's be Rusty. Where is Rusty? It's on YouTube. If you want to be the biggest networker, because it's a global community, you need to be on social media, Discord, Signal, Telegram. These are your eyes and mouth to the world to get opportunity. There's one more. More guesses. All right, so we covered Googling, we covered YouTube, you covered, Telegram, social media. I mean, I would say more than social media, it's so more than Telegram, it's social media, just to clarify. Somebody said GitHub. Please get up. So the reason I give him that is because GitHub is a part of the last skill, which is called debugging. Sit down. So debugging something is your biggest skill set. Remember, in the world of technology, you're not gonna, most of the time, 90% of the time, you're not gonna program something new. You're gonna integrate, you're gonna replicate, you're gonna debug something 90% of the time. And it's only 10% of the time you're writing some fresh code. So, Google. You need to know how to Google to find what you're looking for. Find your, whether it's a piece of code, whether it's people, whether it's information, whether it's knowledge for a particular, product. You need to know how to Google. If you are not a great Googler, you will miss out on a whole bunch of learning experience on your own. And being a Web3 developer, it's not about being here. It's about you being curious about what's out there that you can take and build on top of it. YouTube, how many people have seen Matrix? Like the movie Matrix, Keanu Reeves. Okay, so not many. You should watch it. You know why? Because the technology they use in Matrix to download anything in their mind on a fraction of a second is very close to what YouTube does for you today. Whether it's cooking something in the kitchen, or doing programming, or learning a concept, learning functionally something, it's all there on the YouTube. There is nothing new that a teacher can teach you that's not available on the YouTube. And if you don't like the teacher, change the channel. Right? So YouTube is the key for you to learn and extend your, speed of learning faster than everybody else. Like, you know what you need to learn. But before you graduate, I want you to, scout everything on YouTube that there is. Here's what we will do, guys. I want you guys, I'm going to give you a little homework. And the person who does the most amount of homework, there are rewards, as usual. And these are 2 more rewards we will announce tomorrow, but you should start working on it today. I want you to scout all channels and all YouTube videos that are out there and put in a common Excel file with your name to make sure that we create a database, a repository for all of us before you leave this program. That is helpful to everybody, right? Okay, so I need one volunteer to administer this file. Who can be that? I need one volunteer. One volunteer to manage this file and share with all the 300 people. Hey, by the way, you know what? We need to create a WhatsApp group. We have so many WhatsApp groups, why not one more? Among all of us, so that we can share information. In fact, we have Discord channel always with us. So Here's what we will do. I need one volunteer. There we go. You guys just missed a great gift, by the way. He got it. So I need one volunteer to manage this Excel file, share it with everybody, share it on a Discord channel, let everybody fill out. I want 10 videos from each of you. 10 videos from each of you constitutes to 3,000 videos. Make sure it's not a repetition. Everything about Rust, everything about Polkadot, everything about Substrate that you can find useful. So you will organize that, make sure there are only no repetitions of the videos, and you will be collecting from everybody, make sure everybody does it, right? All right, you know, there is only one problem with this exercise. If you don't do it, there is something called negative marking. So make sure you do that. Now the second homework I'm going to give you, which might take a little more effort, is I want you to capture 10 ideas. I need a volunteer. One more volunteer. There we go. We have a second volunteer. So can you please, both of you, stand up and announce your name and college? What is your shirt size? And yours? Okay. Deepak, do we have our shirts? Can we get 2 medium, please? We have it here, or we are getting that tomorrow? I understand, but do we have the t-shirts here? So 2 medium t-shirts for 2 great volunteers and this is, guys, I'm going to take it back if you don't deliver.
Hi sir, I'm Karim from Marlakshman Reddy College.
Don't tell it to me, tell it to everybody.
Hi guys, myself Karim, I'm from Marlakshman Reddy Institutions, Dundigal.
Hi guys, this is Puneet Khatri from Agma Degree College, Malakpet.
Thank you, Karim. Say your name louder.
Hi guys, this is Puneet Khatri.
Louder.
This is Puneet Khatri.
Puneet Khatri. So again, thank you, Puneet. Thank you, Karim. You guys sit and wait while we get your t-shirts. Again, guys, everything you do here, you earn. Everything you do in Web3, you share. Web3 is all about sharing. That's the biggest skill set you need to own. Web3 is about building, making it open source, and let other people build on top of it. So there are 5 skills. I said 4 earlier. Let's recap. Everybody write this down because you will need it, because I'm going to ask you very, very randomly when I meet you in the corridor. And we are going to repeat it the entire time. Number 1, who will want to say which was the first one we discovered? Skill. Googling. You need to know how to Google. Number 2, YouTube. Number 3, social media. Number 4, debugging. And number 5, sharing. Everything you do in Web3 is sharing. Guys, so these are the 5 skills you need to have. By the way, you have trainers here, very capable trainers, people who came from outside. I will tell you, we are not here to solve your problem. We are here to teach you how to solve a problem. In Web3, You all are problem solvers. And if you don't know how to solve a problem, let me ask you, if somebody is hungry, what do you teach them? Do you give them food? Or do you teach them how to cook? Which one is sustainable? Which will last forever? So do you want me to give you food or do you want me to teach you how to cook? So that's what we're going to do here. All the trainers, all the instructors, all of us are here to teach you how to cook. Bar the lunches. But beyond lunchtime, you're learning here how to cook. My point is, you need to understand that a Web3 developer is the best problem solver in the world today, and you need to use these tools to learn how to do it. You need to master how to Google, how to watch YouTube. There's so many things on YouTube, but what to watch? You need to create, the whole point of GitHub, being able to debug. You need to make sure that you're able to share all of this information. And you need to make sure that you are adopting these 5 characteristics. And if you learn these 5 characteristics, how to do all of this, I'll be honest, you can write not even one single line of code here and you will be a great Web3 developer. But if you do that with writing, a line of code with us, we will extend all the resources that you need. All right, can you give me the t-shirt? Oh. It's too hurry. All right, Kareem, come on the stage. Hey, you saw this on the video and the presentation yesterday. You get what you see. So Kareem, thank you for volunteering.
Thank you. It's my pleasure.
So here is your t-shirt. Yes. And I want you to introduce yourself again to everybody, because everybody is going to get negative marks if you don't manage the file. So if you don't see your name on the file, you know who to go after. So.
Hi guys, myself Karim. I'm from Mahindra Reddy College, Dundigal.
Yeah. So big round of applause. Guys, one of the things I would like to suggest is please show leadership. Please show. And how many people know what is leadership? What is leadership? It's a very confusing word. When I first heard of it, I was like, what is this? Doesn't sound like management. What is leadership? Raise your hands. I want to hear it. Raise your hands. Sure. So I heard putting other people's need beyond ours or before ours, and then taking initiative.
Because everybody has different ideas. Everybody knows what are ideas. But there are very few people who know how to lead that idea. So that's where the leadership comes from. That's where the people should know it about.
Okay, let's get some more opinions. At the back there, I want to hear it from the back. Does anybody know what is leadership? Take a guess. Wait, can you get? I'm getting you guys over. Just keep that thought. Anybody? Hello, hello.
I think leadership is the ability to choose the right path, which gives everyone a advantage for all the members in our team. Like it leads to a right path. to choose, the ability to choose the right path.
Ability to choose a right path. Please bring it down here. Somebody has more to add. It's easy to scream with everybody, right? All right, take it up. Take it up. Go ahead. Make a wild guess. Guys, look, I'm not looking for perfect answers. I didn't have one when I was in your shoes, so don't worry about it. Just take a guess.
Ability to manage the things.
Ability to manage things.
Leading.
And leading. What else? Ability to get things done. More.
Taking initiative.
Taking initiative. Okay?
Assigning right work to right persons.
Assigning right work to right people. Okay? At the back. Providing direction to everyone. Okay? Ability to influence. What else?
Quality to make the team decentralized.
Quality to make a team decentralized. You're getting there. You're getting Web3. You're getting the vibe. You're getting the vibe. I love that. You're getting the vibe. All right, guys. So thank you for opinions, and so there are two things. One is leadership has two definitions: leading from the front and leading from the back. You have to know, and all these definitions are somewhere in the definition of or illustration of leadership. But when you talk about leadership, it's about, like rightly pointed out, looking far ahead, able to see direction, give direction, take initiative. But at the end of the day, the best form of leadership is leading by example. Like if you want 10 people to do what you are doing, or you want 10 people to do something, if you don't do the best, they will not follow you. The leadership is leading from the back means, okay, so there are two forms of leadership I was saying. Leadership from the front and leadership from the back. And this is a quiz question. Everybody, so pay attention. Leadership from the back means that you're letting people take decisions. And you let people sort of drive when required. And when people get stuck, you jump forward and then you show the direction and you lead from the front by doing what you want everybody else to do. And it's not as easy as it seems. It's a very difficult job when you know everything and people in front of you are suggesting something which you may know that is not right, but it will happen to you that in your team there will be 7 bright people or 5 bright people or 3 bright people, and everybody wants to make things happen, and you have to understand, should you lead it from the front or should you lead from the back? You have to make that choice every time when you're working in a team. You lead from the front when the team is stuck, when you know the way. But when you see people leading, the best leaders are the people who are creating more leaders. If you want to be the best leader, you need to know that you need to create more leaders in your team. And when you're leading from the back, you're creating more leaders. When you're leading from the front, you're showing everybody the way. So for you, I will say as a Web3 developer, you need to be a leader, you need to take an initiative. But leadership doesn't mean that you're always working with a team. Leadership even means that when you're acting alone, you are taking the initiative. Leadership has nothing to do with people. Leadership is to do with what you do when you're alone, and you're doing the right thing, and you're taking steps and initiatives to move your future forward. With that, guys, one more participant. Introduce yourself louder.
This is Punit Khatri from Acme Degree College, Malakpet, Hyderabad. BCA first year. I'm currently pursuing BCA first year.
And by the way, everyone, it's your responsibility, and Kareem, to make sure you create an Excel file on Google Docs. For you, you will be collecting the YouTube videos, 10 each, no repetition. If there is any repetition, you will delete that video and the person will see, that he has only 8 videos or 6 videos. For you, an important job that I'm giving it to everybody, you guys need to come up with 10 ideas, each of you. 10 ideas by yourself in Web3, which will be game changers in the future. That means you need to now learn what is Web3. You need to learn what are the ideas, what have people done, like all of this. But you have 2 days to come up with 10 ideas each. And I will make sure that you get up and explain your best idea. So you better be prepared that you should know what ideas you're going to talk about. Or any of the 10 ideas, we look at and say, please explain this idea. At Harvard, they used to do this painful thing called cold calling to all the students. The professor used to walk in every morning, and we are given this booklet, a day before to read before the class. And he would say, Kareem, start talking, right? And then you have to ramble everything that you know about the case, and it was the most painful first 15 minutes where you know that you were praying that you don't want to be called on. But I promise you, before you leave, all 300 people will be called upon and explain ideas. So, my man here is responsible here to capture those 100 ideas, 300 ideas, no, 3,000 ideas, I'm sorry. 10 each from all of you. You're not going to have a common Excel sheet. They're going to email you all the ideas, and no cheating, all right? No sharing ideas. So the 2 homeworks, one, to get all the links on YouTube that you find, 10 each, that will be commonly shared on an Excel sheet with everybody that Kareem will follow. Right, Kareem? The second is we're going to do 10 ideas that all of you will email end of day after. So today is Thursday, Friday, and Saturday. By Saturday evening, I'm going to take a daily report how many he has received. And we will choose the first 10 to make sure they're getting surprises. Sir, no revealing information. All right? All confidential till day after tomorrow. I want 10 ideas and 10 YouTube links. And this is where we learn how to Google, how to YouTube, the first 2 skills that we talk about. Are we on the same page? Does everybody want surprises? All right, so giving t-shirt to our friend. A round of applause. Fantastic. So with that, everyone, thank you so much again. We understand there have been technical challenges, but again, we are doing our best. There are some corporate restrictions from Tech Mahindra for security reasons, so we are a little limited on how quickly we can react to this request. So we are working on it, but at the same time, I expect that when you go back, you are digging it, you are making sure you are the best person, best star that comes out of this galaxy when we leave here in a few days. Thank you so much again. Yeah.
Guys, please note down my email ID.
Email ID, yep.
KHATRI. KHATRI. PUNEET 2000 @gmail.com. KHATRI PUNEET 2000@gmail.com.
All right, one more time. KHATRI, P as in Peter, UNEET, number 2000 at gmail.com. All right, everyone. So with that, I will hand over to our host, Deepak. You're on.
Guys, a huge round of applause once again for such an amazing, inspiring talk. Thank you, sir. Yeah, so I think we did a lot. We covered a lot. We missed a few things. Okay, I'll change the mic, I think. Yeah, so we missed a few things. And I want to tell you what we missed. We missed 2 sessions that were to be taken by Selva sir. Guys, this is for you, right? I know it already. This is for you, so please pay attention. Yeah, you miss it, then you'll start hunting each other to figure out what we said. Yeah, please tell me. You have a doubt? You have a doubt? Okay. Yeah, so we have missed 2 important sessions of Selva sir, but worry not. We have a few more days and we will cover it up and we'll make sure that all of you are up to speed with whatever we have to cover with respect to the session. So do not worry. What we missed today, we'll try to cover up as much as possible tomorrow. Secondly, I think now is time to leave, but before we leave, I just want to take a second, I guess 30 seconds, to tell you guys that we are here. You may have seen that some of the other technical challenges we faced today. But the people who are behind that black screen, you know, they have been at it from morning till the evening. Even after you guys leave, they are sitting there sorting things out for tomorrow. And people from Tech Mahindra are there, people from IBC Media are there. So please give a huge round of applause for spending so much time and energy running left and right to make it possible. And another person who shouldn't go unnoticed is our dear cameraman. Today's entertainment sessions were brilliant, and he covered it brilliantly. And obviously, I mean, I'm not ending the Hackfest today, but since we are giving thanks, I would also like to appreciate the people who are cleaning the premises after us. Yeah, they deserve the highest, huge round of applause. Okay, on that note, okay, fine. Before that, I would let Selva sir address a few important things, and then I'll finish up.
So, guys, please do understand that, you know, a couple of this palette-related stuff and Rust-related stuff you did not, you know, understand well, so don't worry about it. We will have Rust sessions, and we will have a code walkthrough all over again, okay? So, you don't need to worry about that. Another thing, there was a good question by Khatri himself, okay? That when I said that in proof of work, okay, I told you that there is a cryptographic mathematical problem that, you know, the nodes have to solve in order to get the mining reward, right? Who gives the problem? I never told you that. You should have asked that. So big round of applause for Khatri for asking this question. So actually, what really goes on, you see, you have to understand, it's not about listening. You need to analyze what is being told and ask relevant questions. This is the relevant question I was actually expecting. Out of 300, only one guy asked, right? That is the kind of, you know, introspection you need to do with all the statements and the amount of information that is coming your way. So let me tell you like this. How do you become a node? It's pretty simple. If you want to become a part of Bitcoin network, go to their site and you can download their node software, you run it. That software itself generates the problem, and every time one block is mined, okay, the problem is changed, and it becomes even more complex, and more complex, and more complex, and it goes on like that. You got it? So there is no physical entity like a person who is actually coming up with questions and which every miner has to solve that question and give you an answer. Okay? So it has been programmed, the software has been programmed like that. So the mining software itself generates the problem that the miner's machine has to solve to get to the solution. Okay? So basically it's, you have to generate a hash with a specific pattern. So almost most of the times they do it brute force. Okay, so and it's not an easy problem to solve. So it takes time. Okay, and this whole thing has been designed in such a way that one block can be mined every 10 minutes. It's been designed like that. Okay, you want to know more about that? We can definitely talk about this at great lengths. I mean, consensus itself is a Bible. Believe me, okay? Consensus algorithms themselves are a Bible. And every consensus mechanism, believe me, is not 100%. There is no consensus mechanism which is one-size-fits-all solution. There are pros and there are cons. We are getting better and better at it as time progresses. So from proof of work, we came to proof of stake, and then you have so many different consensus algorithms. And every now and then, you find IEEE papers on newer consensus algorithms people are proposing. You will see those as part of the products coming up. Okay? Right, guys. So I think with this we will close for today. Okay? Okay, guys. Bye-bye. See you tomorrow.
Thank you, sir. Excuse me. Guys, are you leaving? No, just we are leaving right now. No, I mean to say the students were there. I'll take just 1 minute. I need to announce some things. That's why I'm asking you to wait. After that, we all can leave. Thank God, right? Long day. I know it's been a long day. Yeah, so one thing, I need 10 volunteers for something very interesting. Raise your hands. Okay, let's go from here to there. Tomorrow I'll do the same. 1, 2, 3, 4. From there, 5, 6, 7, 8. 9. Okay. So I guess my colleague is saying that what we wanted to do has already been covered by you guys. So cancelled out. Sorry about that.
Can I announce?
Yeah, I'll ask her to announce. That would be much better than what I'm doing.
Okay, cool. So hi guys, we from IBC team, we are collecting quick video bites from you students, where like max 20 to 30 seconds of feedback. I think I have covered 22 students as of now. I mean 6 of them from those who raise your hands now. So other than those people, I want 10 people who are going to do that tomorrow, or I'll pick them. You want to volunteer or you want me to pick?
Yeah, are we hearing pick?
You want to volunteer? You want me to pick? Great then, I'll pick. And the one who said that now?
All right, so I'll give you a context to that. The reason we are taking these videos is because, see, everybody is putting in a lot of hard work, including you. You might be shy from speaking on the camera. You might be shy or not expressing what you learned, but we want to archive it because it is important for us to know what students have learned. We are not going to tell you what to say on the camera. It's totally up to you, but we will be putting it on the internet. We want the other students to also know what we are doing here, and we also want you to feel confident about what we are doing here, and if there are any suggestions, we also want to work upon them. Getting my point? Yeah? Does that make sense? Perfect. So please help her out and reach out to her. Volunteer, yeah? Take the initiative. Okay. Another last announcement, I'm really sorry. So you have to go from that gate, all right? Don't make it crazy for the IBC team to, give you directions. All of you, you can see my hand, right? You can see my hand, left, on the right, perfect. So if you see my hand, that's the gate, right? Your flight has to go from that side.
those of you who still have the virtual machine to be copied, please wait, finish that and go. And return the USB pen drives, please. That's IBC property. Okay? Right.
Guys, make sure you copy it. And we have some beverages on the outside. Make sure you pick it. And we gave a huge round of applause to our cleaning, the people who are cleaning these premises after us. So make sure you don't litter. Do not litter. Be professional. All right, that was it for end of the day. Have an amazing night. And just hoping to see you all soon again. Thank you so much.